Oh, good morning out there. It is a nice, balmy morning over here. It means it's time to do some video game development. Just going live for the day. Gonna drink some coffee here, gonna let the stream build itself up a little bit, and then boom, we're gonna jump right into the action and see how much fun we can have today. We'll see how much excitement can be had. Give me a second here. Throw this out to the world. Okay. Oh, Ramses! Did you close to the root of the D? I did, Ramses. Actually, I did. I will show to you in a few minutes or so. I'm gonna go over what the issue was. And it's not completely fixed though, but we're definitely on the right track now. And whew, that was a pain in the ass. Okay, where do I need to do the edits? This page. There we go. Let's see, I want to add. Yep. No, go away. Add one more. Okay. No, that again. Uh-oh. Where's my phone? There's my phone. Okay, perfect. Let there. I think that'll fix the problem for people. Oh, excuse me, guys. It's early in the morning here. Early in the morning. I'm not looking at chat right now. I definitely will be looking at chat here in a moment. Just want to close some stuff down. And I want to hit play over here. I'm going to refresh this. It is early AM, Ramses. It's early in the morning, buddy. After the fact, had to go to bed, so you didn't get to see all of it. I don't think. Yeah, Ramses. Ramis. Well, yeah, don't worry. I'll go over it. I definitely will be going over it. Oh my god, Lumpex, what's up, buddy? What's up? How you doing, Lumpex? Happy Turkey Day for anybody out there that follows the holiday. I know it's probably really early in the morning, and anyone just joining the stream right now, probably not in America. Gonna just take a guess there, and probably does not celebrate Thanksgiving, but that's okay. Happy Turkey Day to you guys as well. Yeah, it's morning, Lumpex. It's morning for me, which means it's morning for everybody else in the entire world. Buddy, I'm awesome. I'm really good. I am really, really good. Just gonna give a few minutes for the stream to kind of warm up, and then we're gonna get started early. I'm not able to do a good 4 or 5 hours today because it is a holiday, but I definitely wanted to get in 2 to 3 hours of development and get it streamed out there for all you fine people. So we're not gonna give our normal, 15 minutes or so of warm up. We're gonna just jump right in real shortly here. Hey Dust, what color scheme are you using, or is it custom? It's dark. It's the dark theme, but since I use Visual Assist, it has its own custom color settings on top of the dark theme. But it's not very. It's custom. If you just use Visual Assist, it would look just like this to you. And I got to say, I really do like their color scheme for the dark, for dark. I think we can change. Right, so there is their normal coloring overrides. Those are their and obviously you could go apply these to Visual Studio itself. Right, I'll hover over each one of these just for a moment, and maybe somebody will write down the RGBs and go do this themselves. I don't know why there's two. There's a RGB top and bottom. I'm not exactly sure why that is. Oh, I'm sorry. One's in hex, one's in decimal. But I'll give you all the colors here. And up on the right, you can see the colors are applying to variables or class names, preprocessor macros methods. Maybe you can go set this up yourself. In the background, some optimization passes to your is an annoying low-end target hit. Oh my god, you're trying to hit a Galaxy S2? Oh my god, man. That is pretty bad. But how are the optimization passes going for it? You don't need a print screen, Dust, to just get out a magic marker and just write directly on your screen the numbers. And then you'll never forget them. Yeah, so those are the colors I use. That's what they apply them to over here on the right. And if you go into Visuals, right, Tools, Options, there should be, not general, text, fonts and colors. Oh, by the way, the font I use the Hack font. You can go download it online. Just Google Hack TTF. There's a whole website on it. I love the Hack font for writing software. It's a great font for that. And then you just have to go through all of this stuff. And there's my foreground and background color. That's default for dark, right? That's the default stuff for dark. You don't have to worry about that. But after that, you're gonna have to go find everything you're looking for to color code it properly. Like, where would there be? Let's see, class. So not C++, but it also applies to C++. Is there just C#? Or is there? Maybe I have to go to the C# specific stuff, because that's class templates. I'm gonna do a little looky-loo here. Maybe I don't want to look at display names, because this is all, I don't know if it uses the C++ like labels, if that's where you need to modify. I don't think so. Instead, all right, let's go to text editor for C#. I don't think they do coloring in here though, if I remember correctly. I guess you're just gonna have to, I don't even know if you can do this or not, to tell you the truth, in default Visual Studio. There's gotta be a way. But anyway, there you go, my friend. There you go. You have to, it's still a stupidly popular phone around the world. I guess so. over at Play Session now, which is pretty good. Most of the Memralics down to a minimum. Next up's crush the artist dreams. Yeah. Isn't that always what happens, Ramses? You get down to your optimization step and it's like, aw, shoot. Sorry, artists. We're gonna have to half your budget. What's that, Lumpex? Oh, when's a C++ stream? I don't know, buddy. We're on a C# project right now, so I don't know when we'll jump back into C++. We will, of course. We will, of course. Yeah, and you know, Rami, is that it happens. Obviously, it'd be better if we could plan better up front on what the art budget's going to be, and not art budget as in dollars, guys, right? But art budget as in resource budget. What's your art resource budget per frame or per scene or whatever it's going to be, right? Your poly counts, your texture sizes, things like that. Expensive UI effects. Those should be the first thing that you slim down. Is your UI effects. An assembly stream when, Kane? Oh, that's a good one, actually. You know, I should think about doing that, Kane. I wonder how bored people would be if I did a like an 8086 assembly stream. I wonder how bored people would be. I think there'd be more bored people out there than you would think. Oh my god, sorry guys, I was not looking over at Live Coding TV. My sincere apologies, let me catch you up there. What's up, Ash? How's it going? And Aligo, how are you guys doing? Happy Turkey Day, things are good over here. A bit of an off-topic question. Did you start from scratch with this project? How can I assess the first video of this setup? Ash, you want to go over to my, I will paste it. If it's not in my profile below, you want to go check out my YouTube channel. And on there should be a playlist where I archive all my live streams. And there should be a specific playlist for Asgard that has everything. And Jenny, thank you so much for following. I appreciate that. But Ash, yeah, so if you go there, it's not really an off-topic question, right? Because that's what we're working on right now. We did start from scratch on this. However, we are using a few third-party libraries to bootstrap us. For instance, we're using a network library. We didn't write our own low-level network library. We're using the Lidgren network library. Very good. And we're also using an entity component system library called Artemis. And we also have a physics library we're using, but I think I made the decision that we're going to toss that away. Not today. We're not really doing anything with physics right now. We're more at a network step. But I think I'm going to throw away the physics library we're using. I think we're going to write our own physics system. Because when I've been thinking about it, I don't really care. I'm not interested in this engine to model extremely accurate rigid body physics. I kind of need a very light physics system. Obviously, we need velocity type integrators, right? Accelerator integrators, some basic collision detection, things like that. But I want a light physics system that I can model client and server side to keep things in step. But more importantly, I need it to be predictive, right? So if I give it the same inputs at the same times on different hardware, different systems, I need to get the same results out. Unfortunately, a lot of physics systems out there are not designed to do that. And so we're going to go write our own to try and get us closer to making that happen. And we don't need like complex physics. I don't even know if we're going to implement joints at all. We definitely will implement like fixtures and shapes on top of bodies, because that's easy. That's how we do collision detection. I don't know if we're going to do like complex joints and things like that. Probably not. Happy Turkey Day, Rick. You want some pie for breakfast? We'll have pie for breakfast. What's holding you back? What's holding you back? Nothing should be holding you back. Be a master of your own dreams. All right, guys. What do you say? Should we get to work? I say we get to work. Let me send out my little tweets. Just so everyone knows what is going on. Okay. Give me a moment, guys. Okay, alrighty. And my tweet is sent. Okay. Pull all of, not you. Let's get you up and running. Get you guys up and running. Stream looks almost correct. I gotta fix one thing on it. I think we're also getting to a point where we're going to start having stream topics for Asgard, right? We've done a little over a week of just like core project development. There really hasn't been like a core topic to focus on a day. I think we're finally getting to the point where we're going to have that, like physics, right? Ghosting systems, stuff like that. Rami's, the green screen is down because I am relocating. After that happens, the green screen will be back up, and you'll see Ghostfaced again. You'll see nothing but floating heads on your stream. Oh, excuse me. Okay, guys. Where we left off last time. Let's fire this bad boy up. Hopefully it fires up. Where we left off last time. Let's get a client going here. We were having trouble synchronizing our client and server simulation, right? We would let our clients move in real time, and then we were pushing all those key state changes to the server so that the server would then also mimic our movement, because we run the same simulation, client and server right now, for the player. So the server should then actually follow in our footsteps, and you know, Bob should be your uncle, right? Everything should sync up. Obviously, when we stop moving, eventually the server should catch up and stop moving in the exact same spot. Unfortunately, what was going on, and I was having a lot of trouble figuring out why we were desynchronizing, was client and server were not staying in step. For some reason, we had different movement points per tick. It was a pain in the ass, right? We couldn't finish it at the end of the stream, so I just spent a little extra time saying, all right, let me rethink what's going on, retrace all of our steps, and figure out what the issue was. It turned out to be a real simple bug, and of course it was a bug introduced by me in how we were doing client-side physics. So if you remember how we do a physics step, we do fixed essentially, right, this is 16 milliseconds. We do a physics step that pushes all the physics forward at 16 milliseconds a step. Now, we can't just run our physics every tick, because delta could be 1 millisecond, delta could be 100 milliseconds. This is the delta since the last time tick was called. So we had an accumulator that would run, and once we had enough accumulated time to equal at least one physics tick, then we know we can execute physics, right? That's what this is. But there's also that edge case where the accumulator was more than one tick. So okay, let's count how many ticks we need, and then execute that many ticks to kind of keep up with a fixed time physics tick, right? So we want to run physics every 16 milliseconds. Sometimes we might have more than 16 milliseconds in a game frame, so we need to execute physics multiple times, right? That's all that's doing. The problem, however, in here was that this is what the bug was. Let me stop debugging everything. Let me stop debugging everything. This was our problem. Anyone see what the problem is when I put delta in our update physics step? Anyone out? Anyone at all? Anybody? Give you guys, since the stream is delayed, let's see. I think Kane understands. That's right, Rami's right. Delta could be any old number, right? We might have accumulated enough for physics tick, but maybe by the time we accumulated enough, delta here was 1 millisecond. Or maybe delta here was 100 milliseconds. And if we pass just straight delta through here, we're gonna adjust all of our velocities by the wrong step. So by changing this to our fixed step, it guaranteed that now client-side movement was in step with server-side movement. Yep, you got it right, Rami's right. Now, how I was able to find this out, I didn't just go and spot this right away, of course. I added some log helping, and I'm going to print this out on screen so we can all see this. I added some log helpers. Let me get this here. Oh, a couple things I did. First of all, I introduced a new variable. We have real time and we have simulation time. Sorry. So in net time, we have real time, which is the actual network time. Real time is used on the server end because that's our real time. Sim time is what we should use client side, which will tell us what is the server time, right? So sim time is the simulated server time from the client. And it's basically based off of our average delay. And this number adjusts as your ping goes up and down. So sim time and real time should be equivalent, should be very, very close to each other if executed at the exact same time, client and server. Out of interest, it can only ever run once. Up here, no, it can run multiple times, right? While the accumulator is greater than or equal to inverse ticks, subtract off an inverse tick, add to a variable here, and we could move this into here. I did this on stream just so it was clear what we were doing. This could run multiple times, right? If accumulator was 2 times the inverse tick rate, or if the accumulator was 3 times the inverse tick rate, you can have a bunch of ticks. What's up, Remix? How you doing, buddy? Excuse me, guys. So back to what we were doing. I added, yeah, we do need that. And I'm just gonna hard code this now. I commented out because we don't need it anymore, but that's fine. We'll put this back. We don't need time. So so first step was I needed to get the client and the server into the same time stream, essentially, right? So we needed to know what the same time stream was. It's very important for us. But more importantly, once I have that time stream, right, we have our formula for calculating a simulation tick ID, which is just our time in the simulation times our ticks per second, because sim time's in seconds. So that's our basic sim ID. If you notice here, I'm taking the one-way ping. I'm doing this because I'm simulating, I have a movement here, but I want to know at one point on the server, is that movement going to get there? Because we're going to take this tick and we're going to instantly transfer it to the server, essentially. It's not exactly synchronized immediately, but basically, right, for debugging purposes. So I take half our ping, which is basically how long does it take for a packet to go from the client to the server, and I add that to our sim time when we calculate the sim ID. So now what I'm doing here is I am calculating a simulation tick ID on when the server should get this exact same, should calculate this exact same data, right? So that's what that ID is, and then we print out what our XY is, right, for the client. Now, if we go over to the server side, we have something very similar. If I can remember where we do this here, which is right here, right? We have a very similar system. We calculate the simulation ID, and I need to move this. Hold on. We calculate the simulation ID, and this is just our real-time times our tick rate, right? This is the sim ID right now in time on the server, and we spit out the exact same data, that sim ID plus the XY location. And Bess, how you doing, buddy? How did I start programming, and any tips? I started programming in junior high school a very, very long time ago, about 20 years ago. Any tips? My number one tip I always give to new developers: do not give up. Never ever do not give up. This is not easy stuff. People don't necessarily get this day one. It takes us a long time to master our craft. Right? The saying goes, it takes 10,000 hours to master something. Software development, no different, right? It takes a long time to truly master this craft. Obviously, you get better and better. Things get easier and easier, but they're hard at first, so just don't give up. Stick with it. Just stick with it. All right, so now we're logging to our trace logger, right? A server tick and our what we calculate at the client side, what the server tick should be for X and Y. So that was the first thing I did. And when I was first running this, and that's when I started noticing that my calculated server tick from the client, what I thought X and Y should be, and what the server was telling me what X and Y was never lining up. I mean, they were lining up sometimes, but as soon as I started moving, you could see that the client was moving a lot faster than the server was from the data I was spitting out, right? So then that's what led me to say, okay, well then I found my delta issue and I fixed that, and let's go see how that looked. I'm going to turn one more thing off on the client so it's not affecting us here. And then we'll talk about that next. First thing I want to do is, give me a moment. I'm gonna change a few things here. And comment that up, okay. All right, so we're gonna get our server running. So now that I fixed that time step, everything should be nice and synchronized, right? Let's go see what's happening. So we have a current, we have a client, we have a server. Oh, I'm also simulating lag and latency at 2 steps. Sorry, there's a bug. And I actually need to apply... this. I'm thinking because otherwise we never get in sync. Okay. I'm trying to turn a system off, but not break the rest of what we're trying to do here. Then let's go back to render. Or, oh, that's fine. We'll just use this. It'll lerp a little bit. That's okay. Code to learn. Oh, I like that, Demonic. Don't learn to code. Code to learn. Whoa, that is deep. That's deep, buddy. Okay. Server on the right, green dot is client controlled entities, right? So if we look here, client, we're sending a tick of 9 of 15. You notice how the server is behind by 5 ticks because we're simulating latency and we're simulating lag. And we simulate, let's see, how much are we simulating? Because I don't remember off the top of my head, but we can go look real quick. And we simulate it on both sides of the equation here. We're simulating about 100 milliseconds of latency. So 100 milliseconds divided by, we do 60 network steps a second, right? So that's 16 milliseconds a step. That's about, and this is rough numbers, right? So that's about 6 frames of difference, and that's roughly right. Right here's 6 frames of difference. Client's 951. We're at 946. It's 4 to 6 frames off, and that's good because we have some jitter in here as well. So that's why the ticks don't line up line by line, right? We're off by just a little bit. But that's quite all right because we don't care about that. We should just got to sync up the 2 ticks together. So now when we move, and that's all we'll do, and then we'll actually shut everything down so we stop generating ticks. And then we can go to the output here. I'm just going to copy this. I'm going to take this into Sublime. I want to do a little bit of, and that was some old data that we had in there. Okay, so let's do some stuff here. Let's find everything that's not a server tick, and let's delete it. Right, so now this is just server ticks. And if we look here, that's what, this is essentially where we did our movement. That's the server ticks that we did our movement on, and that's where our locations were. Let's do the same here, but just for client ticks. Thank you guys so much for the follow. We can come down here and see where we did our movement, right? And I'm gonna pull this off just so we can look at it all side by side. And we'll line it up, right? Make it easy on ourselves. So server tick 5538 we don't move, and then 5539 we move to 28.3. So if we line this up, client 5538, 539, 40, right? You can see now that we should be roughly right on our ticks. And obviously on our server tick, sometimes a tick is missing here. Perfectly okay, as long as everything does sync up correctly. And there's still a bug that we have to go fix, and this data is showing us that bug still. I think we'll find out. So right at 5539 we have 28.3, 39, 28.3, and then more importantly at 540 we should be at 26.67. But if you notice here, we're not. This is, I need, normally this would be here. I have client side diffing and lerping going back. Let's see if we can turn that off. Here, let's actually cancel. I really want to turn that off because it's kind of messing up our data right now because of a different bug. All right, so I do need to turn this off. But then that means I need to, how do I want to do this? How do I want to do this just real quick like? So we're at X and Y. I need to initialize this data. I think I'll just initialize it wherever we set this up. So new there, we'll just do it here. Player state.x is 40, sorry, 80 by 60, nope, 40 by 30. All right, let's try this again. Let me get chat back up here. Hey, Gigabyte, how you doing, buddy? Happy Thanksgiving. Happy Thanksgiving. Let me catch up on chats. Play the audio buffer contents. Oh my god, that's weird. Not code related, but doesn't the music distract you? Or in general, I tried it once, never again. Everyone's different on Viz, right? Everybody's absolutely different. For me, music does not distract me at all. Sorry. Looks engine versus Godot. I would pick Godot. But I'm actually a pretty big fan of the Godot game engine. We actually do some game development in Godot. Okay, let's do this again. Taking off my lerp, and we should now be in perfect sync. All right, so we'll take a little test here. That's all. I just wanted to move once and done. We could turn everything off. Go to our output, grab it all. Right, we're just gonna retrace some of our steps. I can close you down. Have this open. Okay, go here. Make sure this is for our server tick. Replace all. Drop down. So here is our server tick. Okay. Replace everything here for our client tick. Find where we need to go. That's a weird tick number. I wonder if that's interesting. And then we reset. This is probably before we connecting, and then we got connected. We should not be doing that, but okay. Now let's synchronize our swatches, guys. Hopefully we can get some synchronized swatches, right? And if we're not, then we're like, oh, then we should say uh-oh, and we need to go fix some stuff. Oh my god, I'm probably butchering your name horrible. Let me see if I can get this. Abes. I can't do it, buddy. I'm so sorry. I can't. All I see is a bunch of constants. I see two. I see two vowels in your name. Is that even possible? All right, let's take a look at data now. So at client tick, client is where things starts. We're saying at client tick, at simulation tick 530, we should be at 28.3 feet. Unfortunately, we are a tick behind here, right? So at 529, we hit 28.33, and then at the same tick, this should not be happening. This is we gotta look at the server and see what's going on here. Why are we got 7, this should be 528, and then 529. On the same tick, that means, oh, well, what this means is, right, physics ran twice in the same tick, which can happen, but we might need to do a small adjustment to our calculation. But what this is saying is that the client is ahead of schedule, right? By the time we get to 41, we should be at 410, and we're basically 2 frames constantly, constantly 2 frames ahead of the server. Does the server miss ticks? The server doesn't actually miss ticks. It's just how we're it's just our debug logging, right? So in our debug logging, we calculate the sim ID based off of current real time times our tick rate. But remember that this can be called, we're inside an accumulator, and this can be called multiple times in the same time period, right? We should probably take real time times the tick rates of our tick count if we wanted to be extremely accurate here. Client should be better late than never. King. What's up, Quad? How's it going, buddy? And the client could have that same problem, by the way, right? It's just how we're debug logging. However, interesting enough, on the client, we end at 8.3. Whereas on the server's actually going forward one more tick to 6.66, right? This is if you the speed of our entity is 100 meters per second, right? So if we take that, we can move 10 in in 10 milliseconds, we move 1 meter, right? So if we say, all right, 10 milliseconds, we can move 1 meter. And we know that a game tick is 16 milliseconds. If we multiply that by how many meters we can move in that time period, right? 10 meters per millisecond. I'm sorry, 1 meter per millisecond, right? Whoa, 16 times. Sorry, 16 divided by 16 divided by that will give us essentially in 1 tick in 16 milliseconds, we're able to move 1.6 meters. So if I was to take 6.6 and add that, we should get to 8.2, right? Obviously, I have rounding errors, but that's what's going on. It looks like the server is moving 1 more step forward than the client right now. Nah, King, I don't. I probably should fix that, huh? I should probably go fix that. That's a good idea. But what's more interesting, first of all, what we should fix first, is these numbers should match up. And these numbers are not matching up. They're very close. They're very close. But they're not exactly where they need to be. Thanks, Microsoft. I could set up. I have programmable hotkeys on my keyboard. I could add a calculator button. So at 5:32, where do we hit 25? We're at 5:30, right? So essentially, we are 2 ticks ahead. We're actually more ticks. We're actually not that many ticks ahead. This is because we're doing this one-way tick, one-way ping lookup. I'm thinking for a moment here. What do we want to throw into here? We could pass along. We could accumulate our own time. Let's just add that for the moment. Float sim time. And the sim time should be our inverse tick rate times tick, but I gotta go tick plus 1. We gotta, since we just took 1 off of tick, I need to put tick plus 1. This is, oh, actually this is wrong. I need to reverse this, right? Because we're doing while, well, let's just do this how we should be doing this anyway. And now we can just use ticks. So ticks is going to start out at 0, which is fine. So our first rate is just straight up sim time. And then if we add 1 more, it'll be sim time plus the tick rate times 2, blah, 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 right? So in here, instead of using net time, we can use sim time like that. And let's do the same thing on the server. Oh, actually, I can't. Oh, that's right. I can't do this on the server, can I? Oh, yes, I can. Yes, I can. Let's see here. So this will run, we can now use, and let me just grab outside of our while loop bar, and I have a bug, I already know what it is, time. Maybe somebody in chat is going to mention it. What is funny is this is like, so this button must be for those people who manually calculate DPS during battles. It's possible, King. It's optional. Can we wipe, please? Sorry. So we want to use our store time plus our inverse tick rate times ticks. Okay, that's good. On the client, I can't use sim time in here. Because what if the physics step, what if this takes a while to run? Then our next through on the while loop, sim time is going to be changed, right? So I need to store this. So that we're using constant time in our loop. All right, curiously, let's find out what this gives us. Now, we should never have lost in the log, right? We should never have a lost frame. Everything should be on a single frame. Let's go make sure. We're just going to do a little move, and then we just shut it all down. We shut it all down. And go do our same processing back on here. Yes, replace all. Yes, replace all. Go find where movement starts. So easy to do that real quick, right? Okay, so now, things look so much better now, right? Don't things look so much better for to get us started? At tick. We're missing a tick here still, by the way, but that's okay. This tick only happens when there is a client that's actually trying to move. So it's okay. We can still miss ticks here, and that's fine. But when we have data, it should be okay, unless I'm still messing something up. But now at 8:39, same movement. Oh my God, why is that still happening? Why is that still happening? That should not happen. That should not happen. Did I mess up? Did I not build? Let's go look. This is the server. This is the server. I'm grabbing time. Thank you for the follow out there. Actress26, thank you so much. Hey, AS96, what's up? Oh, I know, Screamer, it's a fun game. I'm going to be playing some more of that later today. Okay, so we grab our ticks, right? We grab time. I wonder if I'm getting multiple players out of here. There should only be one player connected. I'm going to take a look, because that could mean we have a different type of bug, right? Oh, wait, hold on. That's in our 4. That's okay. King of Tomorrow! Thank you so much for the follow. There's our accumulator. Okay, good. If our accumulator is going to cause a tick, grab time on the server. Start with our ticks. Take our time plus our ticks we're going through times our tick rate. Yeah, this should never be leading to multiple sim IDs. By spraying electronic spray under the mouse button, but doesn't seem to do the trick anymore. Oh no, King, it might be time for a new mouse. Have you thought about that? What's electronic spray? What is electronic spray? All right, back in our log. Unless, all right, hold on. Let's recheck the log. Let's just recheck the log. And this is not good, by the way. We're at different. Does the server eventually catch up? Okay. We're just gonna look at it here. Thank you so much for the follow. Thank you, thank you. 839, 840, 842. That's a little weird, by the way, because we missed a whole bunch of time here. Why are we missing time? in our tick rates. So 839, and then server 839, 840, 842, 843. There it is, right? Boom, boom. Should not happen. The last time you were making that, Enderkin will be back about the beginning of the year. Electronic cleaner. I don't know what that means. Get to the PlayStation. Wow, Screamer. Holy smokes and wow. It sounds like an episode of X-Files. Yeah. Yeah. We're just flooring here. But because of the tick rates, let's see, this is a float. This is a float of 60. I think I'm just gonna log some more data. And because the client is doing it, well, is the client doing it as well? The client's not doing it, but the client did miss a tick, right? 39, 40, 1, 2, 3, 4, 5, 6, 7, 8, 9, or no, I guess I'm just crazy. The client is fine. Client looks fine unless I'm missing something, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, the client does not look to be missing a step. No beats missing there. On the server, let's re-export. Boom, double. But not only that, we missed 38. So I'm assuming this should be 38. Then 39, 40. We don't get 41 at all. Even though we should have, because that is where 41 should be. This number should be at 41. And then this should be 42, not 41, and then 43. Are we not flooring properly on one side? Are we doing a round? Okay. It's electronic. Oh, contact cleaner. Oh, so just like rubbing alcohol? Are you basically just saying rubbing alcohol? Either rubbing alcohol or something, yeah. Or mineral oil? No, probably not mineral oil. I need to see where this is getting calculated from. Like, what is our data here? So we're going to store this, right? T0. And we know what our tick rate is. Put this back. But more importantly, I want to log T0. And I don't need to log, well, let's also log one more factor. I want to log this whole calculation. Basically, our raw calculation that we're flooring down. And maybe that will shed some light on our problem. Double clicking drives you nuts. I think it's just time for a new mouse, King. It's just new mouse time, buddy. It happens, right? They're not designed to last for too long. You get so many clicks out of them. All right, let's do our normal move. Let's just clear all this data. Let's duplicate our problem. Let's close it all down. Take our outputs. Drop it in. Get just the server ticks. Okay, we can go easily find what we're looking for here. Okay. All right, here's a double tick, right? Here's a double tick. So it's because we are flooring, right? If we were doing a round, this would update to 7, but we don't want a round usually. What was the first number? That's just our total time, right? And our tick time is 16 milliseconds, so this is correct. Just to make sure, right? So if we go 48 minus 36 is 16-ish milliseconds. Is that a rounding error? Because if we actually did... Oh, okay. Oops, wrong number. I wonder if this is just float rounding. If we took this plus... oops, oh, okay. Let me go to another calculator. Right, that's our number. Plus that, we should have 23.45. And if we take this times 60, we should have 1407. That's our bug. It's a float rounding problem. It's pretty new. Oh, that's not cool, King. But sometimes mice just break. Okay, this is a float rounding issue. That's what's going on. This is a float rounding issue. Because we should be getting 1407, right? So if we take 1 divided by 60, if we just do 0, 1, 6. Let's redo this as if it was in float space, right? Where's our duplicates? There we go. Come here. Right, if we take this and we just add 0.016, what do we get? 23.45 times 60, and we still get 1407. Oh, what's going on here? What is going on? Why are we only getting 14? Why is that? 23.43696 plus 0.016 should get us to 23.45295 44282. Hold the phone. We're taking our... Oh, is this getting cast out? Let's try something real quick. Let's close all this. Let's rerun this. Big integer, all of it. Oh my god. Oh my lord, you guys. Just big integer the world. I wish we could. I wish we could. I wish that were possible. Move, close, shut down. Grab our output. At least we're able to do this real fast, right? Replace. Okay, so now... Still have our problem. But let's see if it's the same problem. Plus 0.016 should be 12.43334. Why? What's going on here? What is going on? I don't understand why that's happening. Maybe I have a weird inverse rate. Maybe we should just log this. Instead of logging all of this, I'm just going to log the inverse rate real quick. Let's see what that number is. Maybe I'm not getting the number I'm thinking I'm getting for the inverse tick rate. Nope, that looks right. 0.016. Let's make sure this is the bug we're thinking it is. That's the next step. Let's make sure this is the bug I'm thinking it is. If it's a multiple ticks in the same, multiple steps in the same tick. More data. We just need to log more data. We're gonna find out, Ramis, right? All right, we're gonna move. We should be, yes, obviously, it's repeating, and a double is better precision for it, but I don't think this is a precision rounding problem. It doesn't look like a precision rounding issue. Back to where we move, because if you notice here how tick is always 0, So that's not our problem. It's not this calculation. Because we're actually never running multiple steps. This is the same step, which is then telling me, why are we executing an accumulation? Why are we executing an accumulation in here if it's not at least a tick apart? Because if we go back to our movement, right there, right? So this is not in the same loop. Definitely not in the same loop. They're different calls into tick. So only one time through this loop here. Otherwise, ticks would be incremented. Let me grab a different count just to kind of be on the safe side, to make sure I'm not getting multiple players out of here, even though I don't think that's what's going on. I'm just trying to narrow down all of our possibilities. I want to rule them all out, and then, okay, then we can look at the last thing. Move. Shut it down. Let's just find it in here. Because that's where we should start moving. Oh, actually, I got client and server. Make this easier then. Just make it easy on us, huh? And of course, I'm not going to have any duplicates now, am I, in this run through. All right, we might have to do it again. I want to see a duplicate. Because this is nice and clean. All right, fine. We'll run it again. Should I pass in delta? Not the issue, but still don't know what your base is doing. Yeah, we should pass in delta. Yeah, this is, right, in C#, this is a virtual, the base is a virtual method. We're overriding it, but we want to make sure that the base class still executes. Okay. Move. Grab all your data. Paste it. Replace it. And search it. Okay, there's a double tick. Okay, I just wanted to make sure. All right, so it's not some weird issue where we have two player objects. I mean, it could happen. So I just wanted to double check, right? So that means that we are executing this more often than we should. So I'm going to do some logging. Oops, let's use the log helper. .log. And I'm going to call this time. Make it easy for us to remove everything except this. All right, I want to log straight up delta every tick along with the accumulator. And then when we jump into here, I want to do a log called tick. And actually, let's put it in here, just to be on the safe side. Okay. What does the base class do in the tick method? It can, hold on, I will get to your question here in a second. I just wanted to run all that. What does the base class do in the tick method? It does basic class stuff. For Asgard base, in our tick method, I don't know if we actually do anything. It's, right now it does nothing, right? And is that from Asgard base? Hold on, let me see. This is, I'm sorry, this is from an Asgard server. Asgard server does plenty of things in the tick method. This is how we do our snapshot sending. So this has its own accumulator and doing its own fun stuff for sending world snapshots from server to client. We hook into the tick so that we can update our physics right now because we're just testing. Which friggin' language to make games should I learn first? Whatever language you think you will learn the easiest. Because all of them can be used to make the video games. Okay. We logged some data, right? Let's just grab this data. Let's drop it in here. Let's move this to time. Wait, hold on. Is this going to do what I want to do? This isn't the right data. That's not the right data. What I'm trying to do, stop, go away. There's our time data. Wow, where is this? What's going on? Reverse, no, no, no. Why won't you find my data? Why is it looking in a... Oh, in selection was selected. Okay, good. Replace all. All right, let's just take a little looky-loo here, right? Oh, our time numbers are... Oh, that's fine. They get better. What is that? What the heck is that? Oh, that's our delta, right? Oh, never mind. What am I saying? All right, hold on. What am I logging? So here is... Wait, what? Oh, this is after the accumulation, right? Yeah, okay, so this is after the accumulation. And then we tick. Because we're looking for our inverse tick rate. Just to put it back up there. Right, we're looking for 0.16. If it's greater than or equal to 0.16, we will tick. Not greater, definitely greater. I should put what the new accumulation is going to be. Not greater, is greater. What are we trying to solve here? I need to know when we have a duplicate, right? So I need to recalculate our sim ID when we do a tick, which is time. Let's just put sim ID in here. And I should also put what the new accumulation is, and that means we need to move this up here. We'll get to the bottom of this, guys. We're gonna get to the bottom of this. Oops. All right, let's just comment this out now. Don't need you. I'm out of coffee. It's not cool. Not cool to be out of coffee. All right, let's duplicate our bug. Boop. Even though I'm not writing out our movement anymore, let's see if we can just find a dupe in here. Get rid of everything except my data. What's this? Oh. Why didn't it remove? Oh well. Remove just your lines. Only a couple of them. Okay, so there's our ticks. Here we go. Here's a duplicate tick, right? So we tick, then we have our accumulation. So 0.12, 9, right? We're adding 10, so 22. We're gonna tick again. We're down to 0.006. We add 11, which gives us just over our tick, and then we tick. Then we have the same tick ID, and then we accumulate, and that is not enough. So why did that happen? Well, because this tick should be 454. That's essentially what our bug is. This should be tick 454, and it's getting 453. And that is because is this just a rounding issue? Is this just a rounding issue with accumulating floats for our tick ID instead of doubles? It might be, right? That might be it. Because here it is again. We're gonna miss 462. So we tick here, and now we're down to 007. We're gonna add 10 milliseconds, so we're just barely over the tick. If you notice here, it's when we are just over the tick rate is when this happens, right? I think I need to put in a little more data. I want to know what time is. I want to know what our time is when this happens. Because that's what's coming down to our tick right here, is what is time at right now. Okay. Let's try this one more time. Nothing like logging a bunch of data. Replace. Let's see if we can just find a duplicate tick real quick. There we go. Got lucky, right? Okay, so when this, and look at our duplicate tick, right? It's always very, very close to time. Oh. Why? Oh. That's a little odd. That's a little odd. What am I spitting out here? Comma. There's our time. What is outside? That's our accumulator. That's our accumulator. Okay, so let's shut this down. Sorry. We don't have to keep spitting data out. So this is we were over our time, right? So we did a tick, and we were at 4.406 seconds. Next time through here, we're saying that many seconds have passed since the last tick. So we're gonna add that on to this number, which means that we've accumulated enough time again so that we can tick. But if you notice, the difference between these numbers is only 10 milliseconds. We should not have ticked here. Most of the network live. Yeah, Rams. And the time is stored in doubles. Yeah, I think I'm about to switch to doubles for what we're doing here. But that's what's going on, right? 10 milliseconds have passed in time, not 16 milliseconds. And then right here, you can see that we did two iterations. This is 2 iterations of 21 milliseconds before we tick again. Because we, for some reason, ticked a little too soon there. All right, let's just go switch everything to doubles. It's not that big a deal. Hopefully not that big a deal, right? So if we go to the move server, go to... Let me find all of our tick methods. I'm just going to do this. This will get us started. Won't fix it right away, but just tell me everywhere. Replace everything. Great. We should have a bunch of compile errors now, hopefully. Or a few compile errors. That we can go fix up. So tick double. Where is tick at? Okay. And then we'll step through some stuff too. Delta time. Should be a double. At least our accumulators basically need to be doubles, right? And we should probably do our inverse tick rates as doubles as well. Double. This is coming in as a float. I think we'll be okay there. Let's just store this as a double. Update physics. Need to be doubles now. Pass this down, which is fine for positioning in the world. The rounding error at that stage is okay. Shouldn't I move the FB? Oh, you're right. Sorry. You are absolutely right. Let's go look for 1F. Let's make sure. A few more things we should do. Doubles. Step time, yeah, remove float. And we don't really need to off the constants, right? Because we're not giving it, it'll cast that float to a double, and it's not so horrible. Did a whole conversion mid-project because stuff was getting strange, figured out it was compounding. Yeah, I mean, that's the problem with floats is you can start getting weird compound errors. Gotta understand why you're using a float versus why you're using a double. When it comes to conversions or precision. Lucidino, how's it going, man? Welcome to the stream. Welcome to the stream. We're working on a real-time networking game engine, open source at that. Do I need start time in here? Do I use start time for anything? We don't. I'm going to remove it. We're going to do a little bit of cleanup right now, too. I don't think we use that. We don't use any of that. we use start time here. We should switch this over to doubles too. We definitely should. And our interpolation buff up. Get rid of you. I should probably change this. Oh, but we don't use any start time in here either, do we? Nope, 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 nope. No, we don't. I'm gonna get rid of you. So then we'll pass in a double. And of course, we're gonna have to debug through some of this stuff. Not that big a deal, though. It's not a lot of code. This is on purpose. That stuff's fine. Actually, this can be a float. That's just an interpolation because we're cool like that. Yeah. This is for not the whole thing. Convert that down, it will be okay. Double, not float there. I think we're okay now. I think we're gonna be okay. I knew sounds like it's gonna be a lot of work. Not at all, Lucidio. Well, of course it's gonna be a lot of work, but that's why we're here, man. That's what we're here to have fun like that, right? Gonna have the cam on him at the turkey table. Oh my God, Screamer. Gonna dip it into smashed taters. Oh God, Screamer. Screamer, don't make me do it, cause I will do it. I'll do it. Oh, these are floats still. I'm sorry, I don't know why I did that. Okay. We have everything still up and running. Let's just see what happens now. Let's just run. Let's run with it. Let's run with it. Let's go move here. Why am I not getting server? Oh, we got a bug. We already found our first bug. Okay, let's take off, which is fine. I want to turn this off. All right, we need to step through from the server side, and we're going to do it from the main server here. These aren't used anymore. Get rid of them. From our run method, which actually is even further back. All right, so when we run, these need to get moved into doubles. Move them into doubles. Because that becomes our delta. Let's just make sure tick gets called at a delta level. So we ran once and then we are done. So it looks like we're getting stuck in an infinite loop. Let's go find out why. Twitch is not a dating site? Oh my God, wait, hold on. Twitch is not a dating site. Are people, I'm not using RSA keys, no. That was just an assembly ref file. Are people trying to use Twitch as a dating site? Twitch is not a dating site. I need to know. Give me the scoop. Give me the lowdown. So we have our delta. We have our accumulator. If accumulator is greater than our tick, that's great. We have a lot of ticks because we're passing in a super high accumulation here. That is a really high delta. So basically, we're like iterating through forever, trying to catch up with that. But that's wrong. That's wrong. What's going on? Oops. Let's drop in here. So we start our timer. We get total seconds elapsed. We grab it again. Delta really should be 0, or is it overflowing? Or is it overflowing? I just want to run a little test here. Have you ever seen the reaction on my name is based? Oh, I see. I have. Twitch is not a dating site. I like the name. In fact, I'm a big fan of the name. I'm a real big fan of that. Okay, so what the heck is going on? Our delta is extremely small, right? I mean, obviously it's e to the -6, so this is a very small delta. The question then becomes, when we get into our tick delta, our accumulator right now is 0. Our inverse tick rate is 0. That's our problem. It's like, wait, that's not our issue. This helps if we do this, guys. Let me make sure I don't just have 60 hanging around somewhere as a whole number. Like right here. Would be bad. And we can fix that. Well, that's the problem with floats, guys, right? You will get rounding errors with floats. The question is, are those rounding errors that you can live with? Okay, so that should fix what our problem is. Get rid of this. We can get rid of this. Let's just run it through one time real quick and make sure that we don't have some crazy delta. So accumulator, okay, excellent. We come back through, take all of that off, and we look at our output. All right, we're getting crazy time ticks now, right? I'm just gonna let this tick up. We don't actually have to do anything. I think I just grab this data, drop it in, replace it all. Essentially, we should not see, oh crap, we still see duplicate ticks. We're still seeing some duplicate ticks. Is this... All right, so this might... All right, what's going on? Why is this still going on? I'm a little unhappy right now because this is not 16 millisecond difference, right? Let's take a look at what we're outputting again, just real quick. So we output a time, we output a tick, we get the sim ID, and we get whatever net time is at right now. Thanks. TypeScript is awesome. Oh, I gotta fix. Oh, that's weird on screen. Anyway, I'll fix that later. All right, so we get a tick, right? We actually miss a tick here because this should be 65, not 66, I guess. So if we take this minus this time, that is 0 point. That's at least more than what it should. That's fine, right? Because you're not guaranteed that every 16 milliseconds we're going to get a tick, but at least 16 milliseconds need to pass. And the problem I see with this right here, and I think this is just our accumulator, is what's going on, guys. Right, so this is not 16 milliseconds, but, all right, this is what happened. We ticked at this, we built up an accumulation, we ticked, there was still enough, yeah, so we did a tick, right? Okay, this is what happened. We did a tick. We had some time left over. We had some, this everything is okay. Everything's okay. We had time left over. The next tick in, there was only 10 milliseconds, but we still had 7 in the accumulation buffer, which added up to be another tick. But obviously not 16 milliseconds have elapsed between these two ticks. But that's okay. But that's actually okay because we just want to make sure that we're ticking, that this is happening every 16 milliseconds. It could happen, two ticks could happen in a row just because we've accumulated enough buffer data, right? It's over a second, we should have 60 ticks. But it might not necessarily be exactly evenly spaced every 16 milliseconds. Game Programming Patterns, such an amazing book. I love that book so much. Thank you so much for the follow out there. Who was that? Firesoul. Thank you so much for the follow. So this is just a bug in our in what we're spitting out here. SFML.net got you? I know, dude. New York rocks. I know. Here, if you wanna, here, hold on. New York rocks. Why don't you post a link to the Game Programming Patterns website? Why don't you be a pal? I'm going to take out our log helper. I know what's going on with the accumulation, with our ticks, why SimID is sometimes getting duplicated, and why sometimes we're missing a tick. It's not that we're missing a tick. It's just in my log writing, how I'm calculating the tick ID at that moment in time is a little off, and that's okay. I'm going to go back to this, and I want to get rid of all of this. And maybe I'll move this out of here, because essentially, okay, there's that. But I am glad that we moved the tick system onto doubles instead of floats, because eventually that will run into like weird rounding errors. It's better we do it now than later. We should hopefully get your first paycheck, New York Rocks. Nice. So Game Programming Patterns is a free book you can read online. However, if you can support that guy, definitely support that guy. Buy his hardcover, buy his ebook, buy whatever works for you, but you should definitely purchase that book if you can afford it. It is a really good book, by the way. It is definitely a really good book. What do I want to do here then? And this, of course, is why this also gets off kilter sometimes as well. It's the same type of accumulation system. But is this our bug that we're trying to fix? Let's go back to our original data set. Let's go back to our original data set, guys. Right, what are we trying to see here? What are we trying to solve? What are we trying to investigate? Okay, as we move, and then we close it all down. Back to square one, and nothing wrong with going back to square one. Let's get all the server ticks. Let's get all the client ticks. Let's find where we start moving on the server, and find where we start moving on the client. And we're gonna just line them up, right? Our ticks are way off right now. Whoa, what did I break? All right, so this we gotta go fix real quick. I broke something really bad. Because this should not be tick 188. The tick should be a couple, maybe a tick or two off, if not the exact, but we shouldn't be 600 ticks off. I broke something when we converted. Whoa. Let's see, sim ID, or is it the sim time I'm passing in? Plus one-way ping. It's a double, we're flooring it. That's our sim ID. Sim time is way off. When we update physics, it's sim time. Am I using sim time on the server? No, I'm using real time. I'm using T0, which is time. Our inverse tick rate, this is usually always 0 though. Ticks are always 0, so it should just be time. Yeah. What did I break? Same system here. So inverse tick usually is going to be 0. We should just be using time. Well, for some reason, time is way off. And that should not... We didn't touch anything there. We didn't touch our net time class. Get ping time returns a float. That's okay, though. I mean, it's fine that this returns a float. It's just going to get cast up to a double, because this is a double. Even if this is cast down to a float here, well, all right, let's find out. I don't think that's our problem, but maybe. But maybe. And we can just look at it right here. Client tick. See how client tick is on 29 and server tick's on 400? I broke something. Yeah. Down on me. We're not getting our update. I know what the problem is. Sim time is client time. It's not getting offset by what the server clock is. And I'm gonna go see why or where I broke that. So that's a double now. That is, let's see if this is coming in. Maybe this is never getting called. This might just never be getting called or something. And then we can see why. Down on me. All right, so that is getting called. There's our remote offsets. That's our sim diff. So when I want to get sim time, we take 8 plus 6. Okay. Okay. And now, actually now client and server are synchronized. What? What? All right, I don't have a breakpoint in there. Let me see if I have a race condition. Down on me. So we have a weird little. Oh, there we go. No, now we're on time. Okay, hold on. I think I didn't give enough time for the client to synchronize with the server. So now let's move. I think that was just my problem, and I wasn't paying attention. Client and server are in step as they should be. Since we're just using a simple test harness for our client and server, I'm not waiting for the simulation to synchronize before I start moving, and you really should do that. Otherwise, you start getting weird stuff like this, like what we just saw. All right, but we're in the same sim time here. All right, great. So 22:22, this is looking a lot better, by the way. 23, same time. 24, same time. 25, everything is synchronized exactly how it's supposed to be. So the switch to double might have helped us, actually. All right, so we still have this running. Let's see if we can get ourselves out of sync. Slightly out of sync. I'm just going to go crazy, erratic, all over the place, and see if we ever get to a point where we desync. But if you notice that the server is actually staying nice and synchronized with us, it is lagged behind us. We are simulating about 100 milliseconds of lag, so red will always move after green. And we are not synchronized right now. As you can see, we're not synchronized at all. This could be because of physics. No, I'm not stepping physics anymore. We are way out of sync though, right? Okay, let's go grab all of our data. Let's drop it in and see where we got out of sync. I should write a little utility to sync this up and help us find that problem, right? That could be something we do real quick. But somewhere we do get out of sync. And we might need to have a simpler test because there's just too much data to try and sort through here. Let's just pick a point in random, 6206. Let's go to 6206. We should be, servers thinks we're at 46,668, 6206. We're way off from that. So we already know that we're off there. Let's find another point. Let's try 6101. Let's go back several seconds, 6101. Still way off, okay. I'm just trying to find the point where we desync. Yeah, I'm gonna redo this. Let's see if we can get a much quicker, simpler test to debug through. But if we can solve this small desync issue, everything else that comes after it will be much, much simpler. So we're still synchronized. And I'm gonna swipe all this data away because we're synchronized. I wonder if it is because of physics, but I think I turned the physics system off, so we shouldn't be trying to do collision detection. Oh, there we are, we're desynced. Perfect. Perfect. That's exactly what I wanted to see, right? It thinks we're, and this is good. This is actually really good because this is just one step away. 16.6666, right? 18.3, 1.6 is how fast we move in one tick. So we're off by one. It's an off by one type of tick issue. I like that because that means we're very close to being synchronized. We just got to fix this one little problem. All right, so this is where we start moving. And and this looks like where we desync. So client at 775. There is no 775, but that's okay. So 16, 60. So we go 333130, 333130, 2826 312. Everything is moving nicely. We're not. Okay, so it looks like the client down key state is executing for one extra tick, whereas the server is not getting that down key state. It seems like it's like we're not down anymore, and to me that means we're not sending this down key state to the server. And this is not a dropped packet issue, because if this was a dropped packet issue, the server would go further than the client, because the server didn't get the packet where the key was up, right? So it sees it was down for an extra second, but that's not the case here. The client, the key is down for an extra tick from the server. So this is us either forwarding the physics ahead, desynced from our key states that we're sending to the server. But that's our problem. That's it right there. Let's stop debugging. All right, let's take a look on the client on how we do that. So key states are happening on the UI thread in a very simple manner. Right here, right on key up is essentially what we're looking for. So we get our on key up and we just update our key states right away. However, and this is where we do rendering. Okay, we don't care about that. In the mover system on the client, we are updating physics based off of the state data. So if it's down or not, we will forward the physics. So one extra tick here is running where this state down is true. I wonder if this is a threading issue. Flow. What would you like me to teach you, my friend? So I wonder if this is a threading problem. Because, all right, so physics is running. Key state is down, obviously, here, right? And everything is good. Update physics comes from the tick of the mover system. Okay, let me see what priority the mover system runs at. Let's go through our priorities now. This could be a this could just be a threading problem, and we can solve that. Not the client in our move client. So our mover system run. We call it the render system still. Moves at priority 2, so it's one of the last things that's going to execute. And then after all that executes, we send out the network packet. Basic stuff, you know nothing. Do I live in the US? Boston, Mass, I do. Yes, sir, of course. Thank you for the follow out there so much. Flow, just some basics. Basics. Well, Flow, I'm not good at teaching the basics like that, my friend. There are very good like tutorials and learning material out there that help you learn that stuff. I'm horrible at that. Boston, Mass, happy Thanksgiving to you too. And hey, Preston, what is going down? So if we look at Asgard client in our tick, not in tick. This tick happened. Oh, sorry. Let me go to Asgard base. I'm just gonna get this right in my head from the core, from Asgard base. All right. In our run method, we're gonna tick all the systems first. That means the mover system ticks and forwards us right, for that one tick. We then run tick of delta, which would then be so after all that runs, this is going to execute, which will send a network packet to the server, get client state. So if we go to our move client, get client state. We are going to pack this up, and it is our forward back. So whatever this is, I think this is a threading problem. You're good at teaching the basics, Preston? Well, there you go, buddy. Preston is the man. There we go. Auto it. Essentially, auto it is basically like VB scripting. You want to make bots for games? Oh, flow. That's a little advanced, my friend. That's that you're kind of trying to run. You're trying to sprint before you even have legs. All right, let's go fix our threading problem, and this won't be too difficult. We just need to keep a different synchronized state. Because all of that ticking, all of that stuff is happening in a background thread. It's not on the UI thread. So the UI is able to overwrite our player state data at a different time, and we're not synchronizing that data between the ticks, right? And that's our problem. Just to make sure. Okay, so we're using move client.player_state. So I'm not going to use move client.player_state to make those changes anymore. Instead, I'm going to have my own player state data, local state. And this is all going to change to just local state. So local state, right? That's for up. Make sure down also gets the same treatment. Okay, great. Now we need to synchronize that local state back to the global state at the beginning of the tick. Or at some point that everything can run through on the same tick there. Now the problem is there's no hook really to do that right now. We have our on tick here. We doing anything with this? But this is, when does this happen? Oops, sorry. I just want to see when on tick runs. If it happens after everything, we might be okay. This is after base tick, so this is the very last thing that should happen, just to go away. So I might be able to do it in here. Core system, because that's the very last thing we run, and it's after the base class, and then we come back through and we'll tick everything. Okay, so we'll do it at the end of the tick then. So at the end of the game frame, we're going to synchronize whatever the inputs were back to the main state. So on the next tick, it'll process that data. Which is move client player states. Player state dot forward is equal to local state dot forward, right? Forward, back, left, and right. All right, let's go see if we fix this problem now. Oh, Flo, don't give up, buddy. Don't give up. I'm just saying, there's steps. You can't shortcut the process. Artificial, what's up, Alex? And Wilson, thank you so much for the follow out there. Oh, that's so sweet. Okay, guys, fingers crossed, right? Fingers crossed. No more off by one tick. And we're off by one tick. All right, let's go take a look at this data. Just immediately off by one tick, right? The client at 45, and then when we get to 45 up here, the server is still at 6. All right, let's actually look at the data though correctly. Man, I was so confident that that was going to fix our issue, and I just got slapped in the face. Just got slapped in the face by the data. 8. So, oh no. This is different now. This actually might be a lost packet. This might be a lost packet. If that's the case, that's actually okay because the server will correct us based off of that. Because the client stopped moving, but the server went one more tick, and maybe we dropped a packet. So just to be on the safe side, let's rerun this test. Because that's the next system that we have in here to correct those type of issues. Because lost packets can happen, and you might be off by one tick to the server, but then the server will send back a correction, and then the client will lerp to where it needs to. Oh my God, we're off. Are we always off? Is this... Did I correct this in the wrong way? Did I correct this in the wrong way, everybody? If we're off by the same again, it looks like we're off by the same problem again. Which that doesn't make any sense, but we're gonna debug that. Right, so essentially at 7:07, or one more tick in. One more tick in, we go further up one tick, and the client kind of stops. Oops, no, keep that running. Let me make sure I'm not lerping back. I did turn that off, right? I'm gonna double check. So from XY, straight up state on snapshot, I hope I commented out our update of the state. Okay, good. Okay, so why is the server going forward one extra tick? And the client stops. We sent out all of our data. I'm thinking, I gotta think this one now. And we're off. Yes, that's just Sublime, Fredith, right? It's just Sublime text. Definitely grab Sublime, guys, if you want a good text editor. Okay, so why are we off by a tick? But now we're in the reverse way. We're off by one tick in the reverse order. Is this the server? Are we now running into the problem where the server is processing out of state data? Maybe. Because let me see if I'm processing that data live. Let's go to the move server. We have a callback. This happens on a background thread when on client state comes in. We are then immediately tying that into the physics body. So this could be the same type of problem. Yeah, this is probably the same type of problem. And we need to do this a little differently. What I want to store, we'll have states. We'll say public player state data. We just call it the real state. Calling it the real states. Where do we initialize? Oh, we're on deserialization. I just want to make sure it gets set up. All right, so we're going to feed all of our data, and this should be serialized. Well, we don't serialize on the side, so that's okay for our test. We're going to feed all of our data into state. At the end of the tick, after we get the packet, we will merge state into real state so that the next tick we can use this data. Get rid of you. So we can continue doing this. Well, we get in a... we actually can't do this. What I want to do, okay, say if physcomp.body.userdata is not equal to null, if we've already set some data. Cleansington, thank you so much for the follow. Well, let's just say if null, if it is null, we can just set the state directly, so we can start modifying it. Otherwise, I just want to go to comp body user data dot as a client state packet dot state, which is our held state, equal to this. Update our held state. We don't want to touch the real states. So when a packet comes in, we're going to store it. We'll store it at the end of the tick, which is basically right here. It's the same as in the client, right? And I want to do it after all of this because I want the next frame to process this data. And we should just do it in. I'm gonna move some of this code out. It's getting a little crazy. And we don't use downtime anymore. Private void tick physics double delta, and we'll also have a double time, just like what we do on the client side. Let's grab all of this. Grab all of this. Yep. Move it into here. And we have delta instead of inverse tick rate. Get all players. Get their state data. If they don't have state data, okay, good. Time. T0 is really just time now. We'll calculate it for them to pass in. Okay, great. And now we can just say tick physics. Tick physics of our inverse tick rates. Time is time plus inverse times ticks. Just in case, right? For our debug writing. What's up, Soul Place? How you been, buddy? All right, Ramis. I expect to be fully synced too, buddy. Co-tick. All right, so after we do our accumulation tick, I then want to grab all the players again. It's just test code, right? It's fine. Go through each player, grab its physics components, grab this. All right, so if we have state data, all I want to do is say state data dot real. Not state data. Oh, am I storing player state data? Sorry, I got to make one change here. I want to store the client state packets in here, not the state data anymore. As user data, oops, is the, I want to store the whole packet. Soldner, thank you so much for the follow out there. Yes, it's another way to cast. What's the difference? I don't think there is a difference. I'm trying to remember. It is for a form of polymorphism. I'm trying to remember what the difference is. I think you can only do it for reference types. You cannot cast, essentially you can't do this. Int I equals 0, double D is equal to I as double. This should not work, right? It can only be used for reference and nullable types, because I could say object I is new object, right? And it's completely valid to try and do this of I. This is a valid compile time. This might not be valid at runtime, but if you do an as cast, right? I want to cast I as object. This will return null if the cast fails, right? Whereas a normal cast of object of I might not return null. This might not be castable at all, and you might get something weird, right? The as, if it can't cast to it, returns null, but it can only be done on nullable reference types. Oh, Preston. Oh, Preston. All right, sorry. Back to fixing this up. Make sure I got this right. Okay. On client states, none of this matters anymore. We actually don't use that, but I haven't removed it. This is what matters. Okay, so we're going to store the full client state now. So when we tick physics, this has to be as a client state packet. State. And then we'll say var state data is equal to state.state. Yeah, lots of states going on. And actually, this should be the real state. Yeah, not just state, but we should be operating off the real state. And then here we'll say real, the really real. Now this could be a client state packet. State data dot real state is equal to state data dot real state. At the end of the frame, merge our stored states, the last stored state we got, into the real state, so on the next frame we'll use that. Let's see what this does. I didn't want to run two servers. I want to execute a client. And okay, no problem there. As a client state packet, if it's not null, what's stored in here? User data is an entity. Oh, that's right. I gotta override that. And by the way, you can use the is operator if user data is a client state packet, right? This returns a boolean of true or false if that type can cast to there. And I just want to say if it cannot cast, then overwrite it. Once I finally get our synchronization properly, we got so much refactoring cleanup to do to make this a usable system. All right, so here we go. Here we go. Not synchronized. Why are we not synchronized? And what logging data am I gonna have to put in here to get us synchronized? Let's just go take a look. And why are my ticks off still? Or am I not? Or hold on, no, I'm not off. Okay, good. Okay. Okay. So on client tick 711, we're ahead one tick. We can fix that, by the way. 28, 26, 25, 3, 1, 20, 9, 18, 16, right? 15, 13, 11, and we stop here. The client stops at 11. The server goes on for 2 more ticks now. Huh. Yeah, the server went on for 2 more ticks. The server went on for 2 more ticks of movement. That is weird. So I need to do a little bit of logging in here. I want to add a little bit of logorama. We're logging the tick. We're logging our XY states. Let's also log our, because we're only going to move forward in our test here. Let's log the forward state as well, which would just be 0 or 1, right? True or false. And let's do that on the server. Okay. And our state data dot forward. Really irking me right now on why we're off. On why this is off. Alright, so we're still synchronized. Hopefully we stay synced. And unfortunately, I was not logging the upstates at that point. And obviously we cannot ever get back to sync. Or can we? Since we're an off by 1 issue, if we go up and down, we're way... Are we back? Are we off? We're off still, right? 30, 50, yeah. We're just going to go further and further off. Every time we move, we're going to be off. So let me restart this. Yes, Preston, I'm sure it's because I'm not multiplying. Why would I multiply by 0 somewhere? No, we're off by a tick. It's just a 1 tick off issue. So there's 1 frame where we're applying velocity or not applying velocity, and it's not in sync between client and server. And of course, every time I want to duplicate this now with the upstate, it's in sync. Right? It's just nice and in sync. But then we would not be always off by exactly 1 frame. It would be off by, sometimes we'd be off by lots of frames. And, okay, we're off. Good, perfect. Let's see what we got here. Let's just see what we got here. So that's where we stop moving on the server, right? Okay, good. Let's see what is up. So, first state true, 1134. We're always 1 step, a tick ahead on the server, which we still need to fix, but not our problem, or should not really be our problem here. So you go 26, 25, 23, 21, right? So 16, 16. We actually go, so here's our 16, 16, where it's, this is our last, oh, we do go to 15, right? So we're at 15 true. And then here, obviously at 42, or where it should be 43, I'm sorry, at 42, right? We're one tick away. No, not sharing code. There are 2 separate processes. Yeah, 15, and the next tick after that, we're false. We're not moving anymore, but it's still true here, right? And that's why we're moving 1 extra tick. This could be in ordering. We're one extra tick. One extra tick. That is because... Why is one extra? Why is it down for one extra tick? It got there is the 1143 tick bit cell. It's just on how I log our calculate and log our sim ID in the debug logger. And the ticks don't actually matter, right? The ticks themselves don't matter. That's just a logging convention. And duplicate ticks don't matter either. What matters is how many ticks we execute, right? We want to make sure the same number of ticks, as in, did the client run forward 5 ticks? The server should run forward 5 ticks. Not that the ticks, they could be a duplicate tick number because it might happen at the same time, but we don't use time to forward our velocities, right? It's based off of tick deltas, which are fixed time steps. But what's important here is the server is going 6 ticks forward, where the client's just going forward 5 ticks, right? That's why I'm saying we're off by 1 tick. We move forward 5 ticks on the client, and we move forward 6 ticks on the server, essentially. Okay, so this is happening. We forward through in our tick override on the move server, and it's after everything happens, we update physics. This can come in at any time. Maybe I should log when this comes in. Maybe we should log that. And that might help us. We can log it when we send it. We can log when we receive it from client to server. Yeah, important's the count, not the time. Exactly. I'm thinking how I can log our data to help narrow down our problem. I think I'm gonna log our packet send receive on the state data. I mean, because there is a possibility that it's just coming a tick later. And if it's coming in a tick later, then that means we are definitely going to move forward an extra tick, right? That's just that's networks for you. So let's see. Let's log some more data. Puzzle Gamer, we do have a loop to simulate 5 steps, not based on frame rate. That's correct. That's what, it's a little more complex, right? Because we're getting data in at different time streams. We get data in over the network when it comes in. We have to keep stepping forward physics, right? Based off that data. We don't nothing's tied to a render frame rate. When I say frame, I mean a server frame, as in a server loop. And we step physics at a fixed time step, right? We run physics at 60 frames a second, or we'll step physics every 16 milliseconds. That means on a server frame, it's possible we'll step physics twice. And then the next server frame, the next 3 server frames, 0 physics step, right? And then after that, we'll step physics once, and then once, and then once. Typically, you should step it, it'll step once a frame, or once every other frame, depends on how fast the server executes. Pessimistic concurrency? Oh god, Preston. Why not just eventual concurrency? Sorry. Yeah, let's write out let's log some data here. So we're gonna say this is still server, this is not a tick, this is client state. And we'll simulate so net time dot server time, not system time dot real time times our tick rate. We'll see what tick is this coming in on, which is okay. What do we want to write out? I want to write out essentially the same data. So here dot state dot x, state dot y, and state dot forward. Let's just see what this does. Okay, we're gonna move. We are off. Okay, great. Let's cut everything out that we don't care about. Oops, undo that. I need to adjust this. I just want to grab server now. Remove all. Hopefully I get my ticks in here. Okay, so let's see when we start moving, right? Will fail and sticks his head in the sand versus assume everything will work and sticks his head. Right. Okay, here we go. We get a client state. Whoa. Okay, here's our first client state over the network, right? That comes in at 8:45 that says this is what was on the client. So 2 ticks later, we're going to start moving, which again is fine. And we keep moving. Oh, this is kind of interesting. So we've moved 3 ticks and we've only gotten 1 tick in from the server, which makes sense. We get another tick in that says true, but we are kind of already past that, right? We're already past that, even though it's coming in about same time now. We get another state in that says still true, and this is where the client was, because we're sending that over the wire right now just for debugging purposes. Over not being able to observe his brilliance. 8:49 is still true at 23. And then we keep ticking, of course, true. We keep ticking, of course, true. When do we get a false? So here's the first client state that says we were at 46.6 false, right? This is the problem. The network is coming in later than we are moving. So the physics was able to run 1 more tick before we got this client state in. And in honesty, we actually got, and actually these things, we got these things in at the exact same time. It's that we store it for the next tick, right? So on the next tick, we execute that. I'm thinking that we should process all of our network state data first and then execute our simulation. Otherwise, we're gonna run into, this is, I think, why what our problem is, right here, right? We execute the simulation and then we update our network state. Even though this came in for that tick, we're not processing until the next tick after that, which means we're gonna move forward one when we should not be, in most cases. Okay, let's see if that fixes it then. And how can we process that first? Whoa. Can we process that first? I think we need to make a change to the underlying system. I gotta think for a second here. Because physics essentially ticks in a multi-threaded fashion. Obviously, as we get packets in, we call back and we're good. But is that even a problem? It's definitely going to be a problem, Preston. It's going to be a problem because the client and the server are now out of sync. What's going to happen is the server is going to be sending back the client's positional data, and the client's going to say, hey, I'm out of sync, and it's going to have to work back, right? So it's either going to work forward or back, and it's not going to look good. But yeah, you definitely need to keep it in sync, Preston. Because remember, we're just moving in a small movement. Imagine that we're off by 1, and I keep starting and stopping movement over and over again. Eventually, you build up this huge offset buffer, and it's horrible. Okay, so if we process messages first. If we process messages first instead of doing it in a threaded fashion, Raggy, we could do that. Yeah, let's make a change here, and we'll process server first. So this is how it's happening today, but not too difficult for us to change. Let's collapse some stuff, make some room. What we are doing in start. We are starting up a network thread, which we don't need, by the way. The networking already has a background thread, but we just start this up because we don't want to slow down the server to process packets, but I think we're going to have to. Yeah, Preston, yeah, that we have that system as well, Preston. The problem is you don't want to do it often. That should only happen if you get out of sync for some weird issues, right? For some other issues. Our simple test, we should not be out of sync. And you should definitely interpolate the visuals. You don't, if you're really far away, maybe you want to just pop over there. If it's a small distance, you want to interpolate to there, right? That way it doesn't look all poppy. But those are in kind of bad scenarios. That should not be your common scenario. You should not be constantly adjusting towards the server state. For the most part, you should be in sync with the server state. Okay, so if we're going to make this change, what does the network thread do? Essentially, we're going to get rid of this. And, while true, pump, and we're just going to call this pump network. And this is going to be a blocking call. We're going to pump the network. And this is where things can get kind of screwy because we might never get out of pump network. If somebody is DDoSing us, we're going to get locked in here constantly pumping messages. If there is that many messages kind of queued up in the network buffer. If you're using floating points, won't things get out of sync? Separate issue, but still need to worry about it. Puzzle Gamer, if we're using floats on the client and using floats on the server, and we're using essentially a similar physics model for basic movement, it won't get out of sync because of floats. Unless you're releasing in the US, then kind of bad turns into kind of good. Oh, yeah. All right, so we're gonna pump. If there is no message, instead of continuing, we're going to break. And that will break us out of pumping the network. Otherwise, we're gonna pump, but we'll raise all of our callbacks, right? We're gonna process the network ahead of time, which means in here, we're gonna get rid of you. And then in our tick, so that's the network. In tick, not in tick. In the base. Oh, actually we do. I need to put an override to make this work properly. Because I need to execute all of this before we tick anything. Yeah, I need to execute before I... That's okay. So we have a protected virtual void before tick. And we'll pass in the delta. And we're not going to do anything normally. And then in here, we'll just call before tick. with the Delta. And we can then protected void override of, where am I at? Sorry, don't want to do it in there. Well, I do want to do it in here. This is a connection is an ice system, but I want to make pump network public internal. That's what I need to do. So in the Asgard server, we can then implement protected override void before tick, and in here we just want to call the Bifrost dot pump the network, right? So before we tick anything, make sure the network gets pumped. Pump up the volume. Yeah, but also remember, Puzzle Gamer, yes, you might have desync, you might have floating point errors over desync, but remember, we're constantly sending updates from client and server and back, and we're constantly correcting to the true state. So error buildup over time doesn't factor in here because we're constantly resetting the true state. Essentially 60 times a second, we are making sure we're in sync with the client and the server. So a buildup over time would not happen because of float errors in that case, right? In that case. Okay, so we've made a change on the server end. We're not going to have a background thread. We're just going to have accumulate our tick ahead of time. We actually need to go make a change in the move server now. In here, or we can just make a quick change to use the real state. So in on client state, this is now going to call at the beginning of the game frame, of the server frame. We're going to set our data, and then within the same game frame, we can then process that data. I'm not going to use real state anymore. I'm just going to use state because that's the state that comes in over the wire. And let's just see what happens here. That's a quick change. Let's see if we broke our server completely, by the way, because maybe we did. Let's make sure the server's even able to keep up with data. Looks like we might have broken something. I'm not getting in and out data. What did I do here? Let me double check, make sure we're able to. We're not even ticking physics right now. We're not base ticking here. But the server is getting client state data. I think we are processing so many packets that we're never getting out a pump message. And that, oh, I know, I'm sorry, I know what I gotta fix. We implemented a polling system that guarantees we'll never get out of pump physics, out of the pump message loop. Because we wait for message right here, we'll wait up to 100 seconds for a message, and if we don't get any message, you can move on. Instead, we just want to say, hey, do you have a message right now? Let's see, read message. Right, we just want to read a message off the stack. If there are no messages, boom, get out of here. If there are, we'll process until we have 0 messages in the queue. That showed how the secret service accidentally, whoa. Whoa. All right, I think we might have fixed that. All right, there we go. Server is now able to run. And we are still off. We're still off. And this is annoying me. We're definitely annoying me right now. Paste everything in. Let's replace. Are we off? Oh, no. I think I might be... We're off. But that's because I get client state in, and I'm not using that. What did I do here? But our client tick and our server tick, we're off. But the client state shows it, but I'm not using... Well, I got to move. I got to see what we got here. Got to see what happened. So true. So client state is true at 11:16. So we tick 11:16. So we tick down to 10. Right, we're doing our ticks, and then boom, we get a next tick in of false. But we didn't move anything. This is actually interesting. I think we need to make sure the client is doing the same thing on the network. Because you can see we got 2 packets in over the network where this was true because we did our movement, right? And we say the client state was true. And then on the next packet, client state's false. So that's why that doesn't update at all. But we still processed 2 network ticks in that time. We still processed 2 network ticks. And this could happen. This could definitely happen. So I don't know if this is something we can actually fix. No, Edrican will be back around the beginning of the year. That's crazy, Preston. So we got a tick in, right? And that these synchronize. This is the synchronization. But we ran two physics ticks in the span that it took for us to get another network state in. And that's why we moved ourselves forward. We might need to have a little bit of server logic to pop us back. Why will you never understand C#? Frost Miner, why not? What's so crazy about it that you are having trouble understanding it? Yeah, so we might need to add some server code here to adjust. To basically to pop us back to where. But actually that's really tough because we're not going to be sending positional data from the client to the server. We're just going to be sending key states. I'm sending it right now to help us debug, but that's not normally what would be there. You know what we should maybe not do? We should maybe not apply. Maybe we should not apply key states multiple times from a client state. Maybe. Because this is a hard problem to say how can we correct against, right? Because it seems like, well, we didn't really drop a packet. It's just the physics had to run twice. Probably because on the last time we got client states, it took a little while, and we accumulated more than 16 milliseconds. So we ran 2 physics steps at the same time. Or more than likely, we just ran 2 physics steps, and it just took a while for the next packet to come in. Remember, we are simulating 100 milliseconds with some jitter, right? Because this could just be accounting for jitter. If we have more than 16 milliseconds of jitter, boom, we're gonna run 2 packets here. Or am I overthinking our problem? Should we just say, okay, this is now the server position, one small tick ahead. By the way, 1 tick is just 16 milliseconds. And should we let the client interpolation adjust us up that 1 tick? Python's not worthless. Python's great. We're actually going to be embedding Python, Lua, and JavaScript as scripting language options into our network engine, or into our game engine. Maybe that's what we just need to be doing here, guys. We just need to be lerping ourselves back. We should just let the interpolation and in this case, push us forward a small tick, right? Puzzle Gamer, it gets so complicated because now, remember, we also have physics we have to make sure staying in step on the server. What is step 1 to learning a language like C#? And it really doesn't matter a language like C#, 50. It's really just step 1. You got to learn to write computer. You have to learn to write software, right? So a software language is a tool. Learning to write software, being a software developer, is a skill. Essentially, you have to understand, learn how to model real-world situations in software. Once you can understand how to model real-world situations in software, you can then start figuring out what you need to do about learning a language, right? That's kind of your first step. Ragathan, yeah, well, I don't even need to notify, right? We don't need a buffer the message. We just need to synchronize the client back a step. And we can actually go do that right now. I actually have the code in there, sort of. Actually, the first thing we need to do, let's solve something first. Let's reset our test. Let's assume we're going to live with this as an issue. And I'm not so convinced it really is an issue. Especially if it really is just an off by like 1 or 2 ticks, 16, 30 milliseconds that the server's just going to correct the client back to anyway. Okay, what I want to do is I want to make sure the client and server can be on the same tick. When I say client, I'm sending this tick. It's important that it's the same tick that's on the server. Right? It's important that we get those ticks kind of lined up. So back here, replace all. Let me see how far off on ticks we are. Let's fix that, and then we can do some stuff. I'm still sending that stupid false thing, aren't I? But that's where we move. Let me grab where we move here. Thank you so much for the follow. Thank you. Okay, so the client says in the game simulation world, tick 1577 is when we're first moving. The server thinks that is 1580, so we're behind by 3 whole ticks on sending that. Let me modify, let's get the client into the same message pumping system instead of a multi-threaded approach. Real quick. Pro gamers rock. This is not a game, this is a game engine, good sir. So in the client, we have a very similar setup. Right, we want to get rid of it. Pump, network, internal, while true, this is a read message now. And if we don't get a message, we can break, not continue, okay. And in start, stop, where's our... I don't know if we override run in the client network, but we don't need to. Protected override. Where? Oh, sorry. Protected void override. Oops. Where is it at? What did we do? Sorry, I don't want to do that on here. Getting ahead of myself. We did everything we need to do here. Go away. In the client is where it matters. So there's our tick. Override before tick. We just want to call dot pump the network. Pump up the volume. Okay. Now let's readjust on the client side how we are processing this data. So this data we store, this is definitely on the UI thread. We want to store that data in the mover client when we call tick. I want to do it at the beginning of the tick so that it goes out with the network and then we process it at the same time. Programmers. Oh, what? Huh? Programmers rock, not pro gamers rock. Man, I'm so horrible, guys. I'm horrible. Rami's where, we kind of. Give me a moment. Kind of. We are kind of in sync, Roms. We're actually, the reason we're off sync by one, I'll re-explain it when I show the data. But it's not something that we can easily fix. But we don't need to easily fix it because it will fix itself, is the point. Sorry, I was thinking what I need to do here. We have our player state. This is where we send our packet, right? So get client state. This happens at the end of the frame after we move and all that fun stuff, and that's cool. That's fine. Go to main form. I think we're okay here because this should still be synchronized. Yeah, let's see. Just like I said, Freddy when it's Freddy. Yeah, I'm horrible with names. If you're not new to my stream, you absolutely know how bad I am with names. Auto-correcting problems are the best, right? Right? Okay, so client server tick in sync. Let's see what happens when we move. We're gonna be off by one, more than likely, but we're gonna be okay with it. What I'm trying to make sure is that our tick numbers are in sync when we start moving. Okay, so this is where we start moving. Thank you for the follow out there. So we say we're start moving on tick 1202. And on the server, it's saying that no, that's 1203. We might need to just adjust the calculation a little bit. And then we say we are done moving at 1211. And essentially same dealio, right? We're gonna get done moving at 1212. All right. So is you trying to get around? Yeah, Ron, we fixed the threading issue. We now pump the network for all messages at the beginning of the frame, and then we do everything. So that way we're gonna get network data in first, and then we can process that network data in that frame. And we do the same thing client and server. That means we also send, that will also, well, sending network data happens at any time, right? Because that's a multi-threading thing. Or is it? No, at the end of the, so, all right, so this is what's gonna happen. Beginning of the frame, we're gonna see a, beginning of the client frame, we see that a key state is down. We process that key state. We move our entity one frame. We create a packet to send to the server that says, hey, we just moved one frame at the same packet. Right? So we did that. On the server, we're going to get that packet. It's going to have that key state down. We're going to apply that to the entity, and then we're going to process the physics, which will have that key state down, and then we'll move the entity. So everything should happen in the same tick number, unless I'm calculating tick number incorrectly from client to server. How we calculate it right now, this is for server. For client, is we use half of our ping time, right? Which is how long does it take to go from client just to server, not back. And we add that to our simulation time, which we pass in. And we multiply by our ticks to get our sim ID, and then we floor that. So what, so let's assume that that is pretty close. And we also, when we send out the data, where am I sending the data? Is that in here? That's the client. This is data in. Move client, I think. So when I send the data out, we kind of do the same thing. We get half our ping. If we have a ping, we get our sim time. We create a packet for that, a move data packet, right? And we even tell the snap ID that we're sending off. And then we add this to our player buffer for corrections that come back from the server, so we can course correct ourselves. Because we are simulating ahead of what the server's going to give us, right? We're simulating a whole ping time away. And if we have 200 milliseconds, that means I'm moving 200 milliseconds in front of what the server's going to respond back what my movement is. I'm going to get movement packets for myself 200 milliseconds in the past. So we need to do course correction towards the future like that. So that's why I store all of our movement data. And not just, I don't really care about the right and left. Well, I do actually, but more importantly, what was our states? What was our forward and back states? But I store the right and left so that, I'm sorry, I store, oh, I don't store. Oh, I do store. I want to know what position where we were at that point so we can correct off of that. Starts working on Shinemu 3. What? What is that? Okay. But we're off by 1 in here sometimes. I wonder if I don't like doing that, but does that sync us up reliably? I just want to see real quick. It's a possibility that if we're always off by 1. Okay, get our data. I just want to check where we actually do our movement. So client sends movement at 775. Server gets a tick in. Client. Server gets a tick in at 777. But hold on. I said 77. I'm adding this to the wrong place. I want to add it to here for our log writing. Rotations will come as well, puzzle game, once we get rotations in there. Just like positional data, we'll have rotational data. Yeah, of course. Of course we'll have positional data, rotational data. We just don't do rotations in our test simulation right now. All right, this is where we diverge. So client's 975. The server shows, where's the server showing true? At 979. Wow, we are like way off on what I'm trying to do here, huh? We should not be off by this many ticks. We should definitely not be off by this many ticks. I want to just real quick go back. Tick physics. Oh, crap. I'm updating the server, guys. That's why we keep getting off. Let's make sure I update the client for what I'm trying to do here. Sorry about that. Like, what is going on here? All right. All right. Go ahead and move real quick. Find our data. So clients 467, server is, all right, we're almost there. It's 460, oh, hold on, is that, nope, 467 is our first. All right, so that puts us synchronized, swatchy synchronization. Let's grab the data again. Well, actually, let's clear all of our data. I just want to see if it's still, boop, by 1. Where it changes. So clients true 2484. 2484 is our first server tick. Okay. Let's go with that. But I'm actually going to now comment out all of this because I don't want to log this data right now. We'll turn it back on if we need to. More importantly, that's logging. This is in the client. When I send our packet out, I'm adding 1. So that'll be the ID. On the server, when we grab this data, I actually ignore that ID at the moment, but we do send it. And then we'll come back on the other side in here. So this is getting snapshots back. This is us looking for, all right, so this is what we have. We have a player buffer, right? We have a linked list of a player buffer. Every move we make client side, we store in a linked list, right? We just add to the tail of our linked list all of our input commands on the client and the position we were at that time. When we get a snapshot from the server, we go pull out the us. We're always data point 0 at the moment. We're going to be refactoring a bunch of stuff once we get this working. We pull out our data point, and this is essentially going to be, say, 200 milliseconds in the past, if that's our ping. We need to go through our linked list from head to tail and find the snapshot that matches, because that's basically the frame that we moved 200 milliseconds ago, right? Once we know we found it, we can now get a difference. We were at position X. The server actually says, no, you're at position Y. What's the difference of that? If there is no difference, we move on. It's like, all right, we're completely in sync. That's great. If there is a difference, I'm going to log it for now. I'm going to log it. And we'll see how often we get a difference. And because of our off by 1 issue, every time we stop, boom, we should have at least a 1 tick difference, right, that we got to alert back to. Let's go make sure. Okay, we're connected. Let's move. We stop, and there is our diff, right? And we're off for difference for, what, for life now? I'm gonna clear. Oh, because we're not adjusting, right? We're still off because we're not pushing the client forward. But you can see we're actually off by 2 frames in this case. So if we find a difference, if we found, okay, we have a difference, we need to correct. We know at what point in our movement history of the client we are diffed at. So then what we say is, okay, let's store where we really should be, our real XY, and now let's replay all of our input movement through the physics system on the client as if we were at the real position instead of the position that the client said we were at. So we're saying here we really were. Let's reapply all of our movement. And at the end of this, we're going to come up with an X and Y where we really should be in sync with the server and the client at this point. Now let's find out what the distance is between where we are right now and where we should be, and log that data, right? And what we do is we store that into an XY buffer. We don't render XY. We have a different render XY that we're going to use. And let's put this trace on here. So we store where we should be. In our rendering code is where we do our lerping, right? And I have that code already in place. Just let me send back to render now. 2D rotations are just positions in 1D space. That's right. So every time we want to render, we want to say, all right, do we have a difference between our render position and the data position? If we do have a difference, we can get rid of this. I don't want this in here anymore. If our difference is greater than 2 units, we basically just, we pop to there. We'll just pop there. If it's not, if it's less than 2 units, and this is every render frame, by the way, what we'll do is we'll do a linear interpolation of 10% every frame to approach X, right? We want to basically go from render X to real state X, and that's what we're going to render. Let's see what this does. Let's see if this is good, if it's bad, if it's too springy, right? You can adjust your lerp every frame. You can do this a little bit more dynamically. Okay, so as we move, right, we had to lerp back because the client got ahead of ourselves, but as you can see, we're not any more different, right? Because we're standing still and we're fine. If we move down, we had to adjust ourselves to get back to where we were. And if we move again, so you can see we popped there because our difference was a huge difference. And that's not good. We should not be having such differences. So that means we have a frame calculation issue going on when we have differences like that. Because I expect to see something more along this lines, right? But by the end, we will be synchronized with the server. So now if we're just trying to move up and around, you can see where we're popping and lerping back and forth. It looks really horrible right now. But at the end, of course, we will snap to where we should be. If you're just going back and forth, it's not so bad. And then get back to where we were. We could lerp faster. We can do like a 30% every frame. It'll snap to true position quicker. Ah. Okay. But I think our problem here is our frame numbers are off between client and server. I think that's just what our issue is. Oh. So that's when you do a bigger lerp, right? It's not as smooth. It'll just pop where it needs to go. Boop, boop. Okay. Let's see what's up. We are sending this data to the server already. Let's undo this. So we're gonna get some client stats. We're gonna calculate our SIM ID, and I just wanna spit out the client state dot sim state dot sim where's our ID at? Let me go see. I set it somewhere. I thought I did. Maybe in player state data? Apparently I'm not, so let's just go at it then. Or maybe I'm doing it on the client and I did not synchronize that to the server. That's possible. Okay. So let me update physics. Let me go to the mover client. We do have a snap ID in our, oh, this is in move data. That's just in move data. I need to add this into, so we'll do a packet dot snap ID equals sim ID. And we're gonna go implement this. As a uint. Normal get set. State dot snap snap ID. Not state, just snap ID. is equal to message read you let's just read in right now as a uint. Right, same number of bits. Message.write. We will add a uint writer, just not right this second. Mention with network sync. Dead Reckoning, that's essentially, would Dead Reckoning solve this? Not really, right? Dead Reckoning is based on interpolation and extrapolation. I mean, we're essentially doing Dead Reckoning. But yeah, Dead Reckoning is mostly extrapolation, which we don't really do. We do interpolation. Sorry. Extrapolation is another way to do things, right? It's not bad. It's just a different way. Let's move this. We can move this in here. And just return null in this case. Just want to make sure I'm doing the correct thing here. If client packet is, this should never happen, but better safe than sorry. Okay, so our packet now has the SIM ID that we think it's at. Let's go make sure this is on the server side as well. So get rid of client, move server. What do we call it? Client state packets. Public uint snap ID. And snap ID is message.read int. And now we can grab snap ID, right? Not from state, but from here. Snap ID. Okay, so we're gonna say, we got this at this SIM ID, and you said you thought it was gonna be that SIM ID. And we might just need to send this back. You know how we can completely synchronize this? Since we're getting the snap ID for this, we could store this and push this back to the player so that it knows to synchronize at that time in space. Yeah, maybe in its time stream. We might do that, and that would give us perfect synchronization for our correction logic. But more importantly, what are we getting as I'm not connected? Because I started up 2 servers. Let's do that again. Let's try this properly, yeah? We're not sending the right number. I know why. Phew, excuse me, guys. Whoa. When I write the snap ID, I gotta make... No. I'm just gonna make it an int. I'm just gonna make this easy on ourselves. That'll be okay. And then on the other side as well... For now. But why am I not setting it though? I think I am. I thought I was. Yep. Dead Reckoning, extrapolation, basically the same. In our move client. Oh, wait, what is... Oh, that's fine. Let's convert that to an int. That's okay. So I am definitely setting that. Let's try this again. There we go. So more importantly, are these matching up? See how these are not matching up? Server is at 707, but we got 709 from the client. We're pushing into the future here. Yeah, you're extrapolating to predict in the absence of data. So typically you would use extrapolation, Ramis, if, and we might add it, I don't know, I haven't decided yet. Our system, we render essentially 100 milliseconds in the past, which means that the server has 100 milliseconds to send us enough data for us to move or simulate all the remote entities, right? If, however, your client gets so degraded in its connection that it's not able to receive 100 milliseconds worth of network data, which, by the way, is we send 60 packets a second. So that's about 6 packets in 100 milliseconds. It's plenty of time normally. But if you have such a bad connection and you're not able to get all that data, essentially the remote entity client side won't move at all. It'll just stand still. Or maybe even disappear if we haven't got any packets for it in a while, right? Whereas Dead Reckoning, if that entity was already moving, in the absence of interpolating data, if there is no data, you extrapolate based off of its previous data and you keep it moving forward. And once you resync with the server, eventually that's going to just disappear and pop or snap back, right? That's what rubber banding is. So that's what you would do client side. If you were doing extrapolation server side, yeah, you can move the hitbox slightly in front. We're not going to do that though. The server will just anticipate. It knows what the lag is of each client. It knows everyone is 100 milliseconds behind in render. It can anticipate and deal with that. And we'll have a rollback replay system. Rollback and replay system for hit detection for like raycasts or hit scan type weapons, similar to the source engine, right? That's what the source engine does. It's pretty popular these days to handle things that way. But in this, look, that one is fine. This one's ahead. This one is ahead by a lot. So Jitter is playing hell with us. Essentially, this is what's going on. Jitter is playing hell. We're not able to reliably predict this. Over a short period of time. Yeah, Bragg, it depends on how far apart it is, right? If it's too far apart, you don't want to interpolate. You want to just pop it. Because the interpolation, the problem if it's too far apart and you're constantly out of sync, you're constantly going to be trying to interpolate the render space into the real space, and it can never catch up. Yeah, it just depends on how far. And every game is different, right? You can always interpolate over great distances. Of course, you can do that. And you can do that over a short time scale, and it looks like they'll just zoom, snap back in a zoom fashion. You can just pop them back. You can do all types of stuff. So that case, it was in sync. In this one, we were 2 ahead, right? We're ahead. And sometimes we catch back up, and then it gets ahead, and then we catch back up. So essentially what this is saying is there's going to be no way for us to use a snap ID for what we're trying to do. Because it's never going to be synchronized, right? In that sense. But what I could do, we could store this data we could have a circular buffer that we store this data for a couple of seconds. So hold on, guys. I gotta eat a biscuit. I gotta eat a little chocolate biscuit here. I'm hungry. Let me get my chat up too. This is good. Okay, sorry. What we could do, we could store the snap ID offset and send that back to the client so it knows how to synchronize. And maybe we'll do that. Actually, it's not a horrible idea, to tell you the truth. Okay, I'm just going to store this as for now, just to make sure it'll work. Oop, not here. This is where we get this data in, right? Let's have a dictionary of int to int of snap offsets. And we need to store this per player and all this fun stuff. And if this works right, like I said, lots of refactoring we got to do. What I want to do is say, and I don't actually want to store it here, because we're storing the data. Okay, great. I want to store it in when we tick the physics, right? When we actually are gonna synchronize our data movement. So in here, I want to say snap offset of, and this is where we need to grab this back. What's the current simulation ID that we're at? And we do have multiple sim IDs, don't we? But we're just going to use essentially the latest sim ID, and we'll make sure the client can handle that. Is equal to the state data that we got at the snap ID. Make this a UN. Right, so now we have a lookup of at the server snap, and when you applied this movement, what did the client think its snap ID was? And this is in the move server, right? I'm just gonna make this public because we're gonna cheat. Because we need to send back get player view data. I'm gonna go into our move data. Oh, I actually have an no, that's the wrong ID. I'm gonna add a public int snap ID. Into the move data. So when I'm getting player data, this is gonna get the player. I can then say move data. I only want to set this for the player. Snap ID is equal to and this is the data right now. So yeah. Which means, hold on, I gotta change this. I gotta change something. We're gonna get this data in. Oops. I'm thinking. Maybe I don't need to do this here. Maybe I can just do this here. Did I remove my? I remove it. I did. Access can just be private. Dictionary. UN int snap offsets. Using var and C#. Yes, sir. Are you not a fan of the var? Don't be afraid of var, guys. Don't be afraid of var. Don't be afraid of auto and C++. Whoever told you that var and auto are bad people. var and auto are perfectly acceptable. Obviously, not in every case, right? Right? Not in every case, but they are fine. Sorry. Okay. I'm storing the snap offset, right? For when we got in data, and what was that actually on the server? Yeah, absolutely don't use var in a unit test. If you don't have to use auto in your solution, nice. You're hot. Absolutely, Snarf, right? That's the exact time when var is fine. If you can defer what var is. And that's also a good point too, Dan, right? Self-commenting code can also infer var. The other time where var is okay and you don't know where, if you can't infer what's on the right side, if I do like, if something like this is also acceptable, right? Var x equals get lookup data. Obviously, if I just do this and I want to go use x for something, don't use var here, because I don't know what get lookup data returns. It returns lookup data, but I don't know what type it is, unless I'm just doing this, right? Get lookup data, process lookup data, x. This is acceptable. This is fine. You can use var here, right? Obviously, you can also rewrite this to just be this. However, sometimes that makes debugging a little difficult if you need to step through on a debugger, so this is a little easier from a debug standpoint. And this is fine because I don't care what x is. I'm passing x through, and I'm only doing this to make my debugging life a little easier. Have no idea who this beanie man on their TV is. Oh, Screamer. Do you have... What are you doing, Screamer? Okay, so... We're storing at real time. What did the snapshot think it was? When we now send this back out... I want to set the snap ID... And we need to look up, that's what I was going to get before I got sidetracked. We need to recalculate what the simulation ID is. We want to say, and we'll get sim ID, and then we'll have an int of snap ID is equal to, by default, we're going to do a lookup, right? So if snap offsets try get value of sim ID out of snap ID. If we can't find that, we'll say, because we need to send something, we'll just say it's the sim ID, which should be very close. And this really should never, hopefully never happen as an int. And then we can just store the snap ID. All right, so move data. Not the best place to put it until we start cleaning all this up. Move data on the client. Public int snap ID. Is that where I wanted to put that? It is. Where is our snapshot packets? Because we need to serialize and deserialize. Data.snapID is message read int. Do that same thing on the server. Snapshot packet is message.write point.snapID. Apparently I added this already. This is on the client. Where am I referencing this from? I'm putting this in. See where you compare. I'm already supposed to send a snap ID. Oh man. Let me recheck some stuff here, guys. Let me just go from the server side. In our move data. Our move data did not have a snap ID. Let me go to our snapshot packet. I think I have just stored... Oh, you know what? I'm just storing that. That's fine. I know what I'm using it for. And that's okay. We'll call this the remote snap ID. And then in the packet, make sure that's coming across. Okay. And then more importantly, where we process diffs on the client, we're going to do a search for... Let's render... right, we're looking at our snap ID that we've already stored. Excellent. More importantly, I don't want to look at the snap packet ID. I want to look at player data. Got remote snap ID. I can just convert you to an int for now. Whew. I have no idea. Hold on, let me catch up. Remove snap ID, is that what I called it? You know what? I'm gonna keep remove snap ID, Rag, because I need to remove it. Remove remote. It's fine. It's fine. Are we still okay? We're still writing out a diff. We're just gonna try this and see if I got it all right first time out. Almost a 0 chance that I got it all correct, right? So we're processing a diff, because remember, we're off usually by 1. Let me stop debugging. I got too much stuff I'm spitting out that I want to get rid of. Man, we got to solve this here real quick because we're starting to build up a lot of technical debt here. That's a pain in the ass. Get rid of you. Okay, now on the client, I still want to write that data out, but I want to get from not the snap packet ID, right, but from player data dot remove snap ID. Okay. We're definitely going to still have a diff. I just want to make sure we're not diffing out by like 5 or constantly. It should always be when we stop, right? There's that 1 or 2 packets as we catch up in the buffer where it's off by 1 tick, that 1.6. So that's what I'm looking for. And no, we're off by quite a bit still. What is going on? Sorry, we're going to have to spit out some data on the server. Because this has not changed a single thing, and it should have. Fine on you. Fine on you. Let me make sure I'm setting this data. We set the sim ID right, which we've always been doing, and we're also sending that out on the packet. All right, so let's get some server-side logging in. So we'll go back to logging this. When a sim comes in, what's the snap ID? But I also now want to log when we write out data. When I write data out, string interpolation, right? When I write data out, in this case, great. Let's log client send. What's our current sim ID and the lookup, the snap ID, right? Let's see if this is off for some reason. Because if these are off, then nothing else will work. Okay, let's look at some data here. So we get a client stat. I want to see where it's different. Oh, that's right. We're using the last. And on the client, I'm using the first. But more importantly, when I get 595, I'm sending ahead of time. I don't have 596. I'm getting 610, right? 612. Sometimes we're not sending. So we stat 620, 623. See right? No, this is fine. We stat 668. No, here it is. This is bad, right? I'm at 668, and then now we're saying, well, I need to send 669. Oh, Gulliver. Gulliver. Oh, Gulliver. Gulliver. Ignore Gulliver, guys. Ignore Gulliver. By the way, Gulliver, happy Thanksgiving. Happy Thanksgiving. All right, so why is this going on? Why is this going on? Right? We're statting 668. Yeah, so this is definitely an issue. That's gonna cause us some issue. That's gonna cause us some issues. We get a packet in at the start, right? We get all of our packets in at the start of the frame, and we say, okay, what's our current simulation tick at the start of the game frame? I'm thinking that we might need to change up our strategy on sim IDs. I'm thinking that's might be what we need to do. For my garage, I'm not brewing right now because I'm moving. I'll be brewing again the start of the year. I'll get the brew going again, man. Yeah, okay, so we get a sim ID based off of real time, right? The problem is this is at when all data's coming in. We might get more data after this. Real time might tick forward, and obviously in this case it is ticking forward just enough that when I want to send data back out, when I'm sending data back out, we have a different real time, so we're calculating a different simulation ID. Don't forget. I won't forget, Gulliver. I won't forget. Never forget! And that is what's up, guys. Okay. How can we maybe solve this then? And actually, in truth, right, we should not be trying to just send real live data. We should be keeping a buffer of our move data for each player because we have to do our replay system. And that buffer is what we should be streaming out to the clients, not necessarily this. I will be turkeying it, Toby. Yes. Yes. I will definitely be turkeying it up. Okay. I'm almost thinking we should have a simulation time that we capture at the beginning of a frame start, and we don't update that simulation time for that whole frame. You guys know what I mean? You know what I'm talking about? And that way we could get, we should hopefully get sane ticks out of it. Will that work? So I'm thinking to myself in my head, will that do it? You're an American Spy in the UK? I've had to try really hard this year to do something for Thanksgiving. Nice. How's it going in the UK? Bucket Orange. How's it going over there? Yeah. So that won't really work. I don't think that will really work. But what we should, so honestly, what we should be doing is our simulation ID should not be tied to time. Our simulation ID should essentially be tied to how many steps of the physics system have we gone through. All of them just play Christmas music? Wow, they've been doing it for 3 weeks. Wow, that's, they just jumped right into Christmas season, huh? But that's what we should be doing. We should not be tying a simulation tick based off of time. We should have a simulation tick that increments on our physics steps and synchronize that way, right? That's our problem. That's our problem right now. That's why we need to refactor our game. Because when we base it off of time, right, you've seen that sometimes we don't get a tick. Sometimes we have duplicate ticks at the same tick. And that plays hell with us trying to synchronize network simulations. Selling gingerbread cookies? Man, I love me some gingerbread cookies, Ragathan. Those are good. Those are pretty good. In fact, I have a gingerbread-like cookie right here. My real estate agent gave me this huge box of international biscuits. So this is a biscuit from Germany, and this is very gingerbready. It's not a gingerbread cookie, but it's a ginger-like snack. It's really delicious. I'm eating one right now. I'm eating one right now. They don't sell pumpkin pie. Oh my God. Baccarat, you gotta move right now. Get out of the UK. Do not stay. Don't stay there for another moment. Okay, guys, we gotta make some moves here. We gotta make some changes here. Where is my net time class? Under network. We're gonna add, just so we can have a global time for this, or state, public, static, uint. We're gonna call this our, I'm just gonna call it, what do I wanna call this? Our sim tick, right? Simulation tick. Let's get in set. Oops. And we're not gonna keep this in sync, by the way. What the hell is going on? I don't know what's going on right now. This is all craziness. What did I just get rid of? Sim time, right? Public. The undo buffer for Visual Studio just freaked out. Sim time. You go away. And this needs to be a public static uint for our what was I gonna call it? Our sim tick. Sim time. I think that fixed everything. So we don't need to synchronize this simulation tick between client and server. Each node is going to have its own simulation tick ID. That's okay as long as we know how to deal with the time streams of those sim ticks, right? And we already have that system, right? The client is going to send its sim tick with its movement data, and we'll make sure we send that back so that it can synchronize its own movement. But we're going to send a sim tick. We're going to have a sim tick that we send back and forth. Okay, so if we have a sim tick in the server, Let's go to the our move server. Where do we apply physics? Our simulated physics right now. Essentially, I want to say nettime.simtick++. I want to, and we're gonna basically first simtick of the day will be simtick 1. Simtick 0, maybe we'll reserve that as a special identifier if we need to like reset or whatever. But essentially, we're gonna have simtick 1 as our first tick, and every time we tick physics, boom, simtick's gonna go up by 1, right? Excellente. Excellente. And that means if we tick physics 2, 3, 4 times in one server frame, okay, I don't care. I don't care at that point. Now, next phase, when we send all of this data back to the client, right? When we send a snapshot 60 times a second to the client, I need to update our tick in there. So when we send a snapshot, see I'm calculating a snap ID right now. Let's get rid of calculating that snap ID. I should just be using nettime.simtick. What was the simulation tick? Because remember, we're now in a single threaded loop. Send snapshot happens after we integrate all of our physics. So all of our physics will be integrated on that snap ID we just set. So snap ID 1, integrate all of our physics, send out tick 1. Now, if for some reason in that same frame we ran physics 3 times, that means we're going to send simtick 1, then we run physics 3 times. The next time we'll send simtick 4, right? Basically, we're not going to send 2 and 3 because we executed those quicker than we send on the network, and that's fine. This is not the network send rate. This is the physics send rate, which is divorced from our network send rate. So we'll make sure we send that. On the client side, in our move client, when do we grab? Remember where I get snapshot data. I think I do it in here. On a snapshot, on snapshots, we, okay, yes, that's fine. No, sorry, that's not the snapshot I'm looking for. I think we just need to go to Asgard client. Is where we do snapshotting, or we should be. There it is on snapshots. We, that's right, remove there. We actually recalculate this. I think I'm gonna keep this in here. And instead of using sim time, I'm gonna use real time. Yeah, which is just now. This is only for the interpolation buffer at this point. So we're rewriting it to local time because we use the ID to make sure we can go back 100 milliseconds, but that's from client time. So this is fine. So I just want to recalculate this as client time. This should keep this fine, as long as we're doing the same thing correctly when we actually go back. Thank you for the follow out there. I do appreciate that. Sorry, one more thing I gotta look at on the client. When we get interpolation objects, I don't want to use sim time. That would have been bad. I want to use real time, which is already afloat. All right, so that'll keep our interpolation buffer up to snuff because we actually don't use the that ID. Now on the client, in our mover system, where we are updating physics, we just want to go nettime.simtick++, right? Same situation. Want to keep this nice and synchronized. Hello, Wilson. Hello. Thank you for following, by the way. How are you doing today, Wilson? Happy Thanksgiving. Update physics, move, great, excellent, awesome. I like it. Just thinking where the next phase is of our data. I believe it's in move client. We got stuff all over the place for us to refactor. In here, I don't want to send a sim ID anymore. Right, this is going to happen after I integrate physics. At the end of it, we're going to try and push this up to the server. This should just be nettime.simtick as our snap ID. Wait, whoa. Yeah, actually, yes, snap, same. Oh my God, what does that do? What does that do? Control T. What is Control T doing? Why is Control T doing that? It's inverting D and I. Anyway, I meant to hit undo, but that's fine. Nettime.simtick. We want to set, right, we're going to send this move data that, because it's in this frame, what was the ending of our physics snap? Let's send that over to the server, and we want to make sure that stays synchronized so that we get this back. So let's put it in the packet, because this goes in our player buffer. This goes out to the server. Now, coming back down, because we are already keeping the differences there. Hopefully we'll be... Oh, we got to make a change on the server for that. On the move server. When we get a packet in, right, in our snapshot offset, we don't want to use SimID anymore. That's bad. Go away, bad SimID. Instead, I want to say at nettime. Our current SimTick. Or do I want to... Actually, I think I want to wait until after I integrate. This is after... No. We just got this packet in. This packet happens... This SimTick's going to update. This SimTick's not going to be the same. In the best case scenario, it's just going to be +1, but it could actually be a couple of ticks later. For testing, I'm just do +1. We're going to assume that we're able to get physics done in 1 tick, but that's probably not always the case. But okay. It might always be the case. I don't know. Let me just get some stuff. So client state. We had this right. This was the snap ID, right? We have to do this a little differently. I have to... Oh, you know what? I know where I can do this. I have the snap ID. We're storing the client state. Just don't do this. Don't be a dummy. Don't do this here. We update our SimTick, right? We're updating all our integrations. Store it right now. And grab the state from here. State data. Oh, not state data. From state. From the packet. And just use whatever the SimTick is. And if this runs multiple times, that's fine. That's fine. I just want to know what I'm about to send back to the server from our snap ID. Oh, that's perfect. That's perfect. And I'm going to comment you out for now. Now, when we send this back to the server, I think that doesn't have to be, or it does have to be updated. Because we are calculating a stupid sim ID again, right? So we have a snap ID. I'm going to try and get our nettime.current SimTick, because that's what we should. We just integrated all the physics. Now I want to push it back to the server. This should be correct. We actually should now find that snap ID. And if we don't have a snap ID, we're going to still use the SimTick, and Bob will be your uncle. And I think that's it. Is that it? Yeah, I don't know, I'm just gonna run this. I'm gonna find out. Let's see how bad we just broke the entire world. You think we broke everything, guys? Is there a chance? Is there a chance? All right, so we definitely broke some stuff, but not everything is broken. Not everything is broken. Because we're still moving. We're just moving at crazy speeds. So we're gonna have to now take a step back. We just changed a whole bunch of stuff. Let's find out exactly what we broke. First thing I'm gonna do real quick is turn off our diffing approach. On snapshots. Because we might still be using a sim ID somewhere, and that's fine, we'll find it. But I wanna turn off this. I'm gonna just comment you out. Right, I don't wanna adjust our diff. And I do want to send up our login again. Not in render, in our mover system. I'm going to do our log helper. And instead of a sim ID, this essentially should just be our sim tick. And these aren't going to match, by the way. Like, I'm going to send sim tick 12 on the server. It's going to be current sim tick is 40. But I'm going to log, but we do send the sim tick, so I'm going to log that with it. So we can see how are we off and where we're at and are we in sync. So on the server, in the move server, when we integrate physics up here, right? When I send my snapshot, this is all of our log data. I want to bring this back in. I don't need you at all anymore. And instead of sim ID, we'll go net time. Actually, we won't even say net time. We'll just say what was the snap ID from the client. Oops. And that should be, those should be synchronized. Let's see if they're synchronized. Even before we move, the data should be synchronized here. Clients, I don't see any server here. There's server. Okay, so it's server's there. Let's move. Whoop. Let's copy all our data and see what's what. Just gotta come up here, replace. Darn it. Control H, replace. You go away. And let's move up to where we start moving. Let's, I don't want to run a command. The server got almost no data. That's so weird. Oh, that makes sense though, because our ticks don't move unless they come in from a client. That's actually very helpful on how we change this. But as you can see, something is amiss here, right? That should be 820. We should be getting client tick 820. That was what I sent. Let's go see why that is off. So let me just terminate everything here. State has a snap ID, but is that the ID that I'm looking for? Hold the horses here. When I send this data, this is going to get client states, and we're going to return this packet, right? Client state packets. I'm sending the packet has a snap ID. I'm sending that as our current simulation tick, and that's player state data, and that's snap ID. And that's in the player state data. Not in our, I broke something here. I don't know if I'm using that. Let me take a look here. In our client state packet, we have a snap ID, but we also have in the move data. So, but that's fine. So when I serialize, we are serializing the snap ID. Okay. Now on the server end, we have a snap ID, and we do deserialize it. We do deserialize it. Move server. When we get that in, on client state, excuse me. We have our client state. We just set it into user data. This will happen first. And then we will get our physics tick here. And this will have our state. Yeah, that's so weird. Something way off. This tick 27 should not be what we're looking for. Let me run this again. And we can debug. Not yet. Let's get a client connected. Now if I pop in here, right, snap ID is 29, 29, uh-oh. All right, so let's look on the deserialization for client state packet and see what's up here. 730 is fine there. I'm overriding this somewhere. Let's raise our callback. I just want to step through. Somewhere I am overriding that data. And that's not good. Oh! I'm being a dummy. I don't need to do this anymore. Let me get rid of all this. I found it. That was the first time we set the packet data, because remember I was just overriding client state for a while. All right, that'll fix it. All right, so let's get a move here. Boop. And let's see what we got. Replace all. Replace all. Find where we moved. Right, find where we moved. Okay, let's see if we are synchronized now. So 250 is where we start moving. And 250, 251, 252. We start moving all the way to 258. This is actually really awesome because this is perfectly synchronized at the moment. Right, 258 is false. On here, 258 is false. We're not moving. These are perfect. And this isn't the data coming back, by the way, from the server. Just to make sure, let's double check. This should be our calculated data that's live. Yep, that's our calculated position. That's awesome. And now we're going to get the right state snap ID on there. Let's see if things are looking better. Everything I think is going to be nice and synchronized right now. I have a feeling that we're going to be super synced. We're going to be synchronized. Let's find out, yeah? We're just going to hide that data. I don't want to even see it right now. Actually, can you guys see this on screen? Okay, you can. Perfect. All right, so we're slightly off from the server still. That's okay. Remember, we still have that possible one frame issue. And we have this data here. We can actually go look at and see when that happened. But it should not be an ID off issue anymore. That's going to be fixed. And we can get our client side change back in there. And things will look better. So 638, everything is going along nicely. True at 15. Uh-oh, that's not good. Or am I looking at this data wrong? We are false at 648, right? We're false at 648, but we're at 15, and the server went boop. The server went one less step than us. Is what this is saying, right? That the client went to 15, the server did not make that. We could have lost a packet there. Wait, no, hold on. Could we have lost a packet there? No, we could. If we lost a packet, the server would have went further because the key would have been down longer. Essentially, 648. It's saying it's down. We're 646. 645. 645 we're synchronized, right? So if we get this a little lower here. Put this in stacked order there. Okay. 645. We're synchronized. 646. We're synchronized. And we're still true. 647. The client went 1415 with the state of down. But there is no 647 in here. No 647. Why? We dropped 647. And that could be, this is probably because we didn't need to run a physics step right there, right? Because we have physics running in an accumulator, and there probably wasn't enough time to run physics yet. Yeah, that's what's going on. That's what's going on. We didn't have enough time to run physics yet. So now we go to another game frame, and at the beginning of the game frame, we collect all of the incoming packets, and we got a packet from the server, from the client, that said the key's now up. So essentially, we dropped a packet. Essentially, we dropped a movement. That's our problem. That's the problem of the day. We just dropped a packet. So we could actually solve for that by keeping a buffer of the incoming data movements from the client on the server. And as we run through the physics, run through those data packets, don't lose the data packets, right? And adjust for the missing packet that we would have dropped, right? Like we should have gotten 247, and we should have executed that, and we would have seen at 247 that we should have continued moving, and yeah. Okay, so we know how to fix that. We know the problem with that now. That's amazing, by the way, that we have uncovered our issue. We're not going to fix it right this second, but we will. What I want to check out now, though, is does our interpolation data still work at the same time? I'm going to turn off my logging, and I'm going to turn our diff buffer back on and see how far off we are in the diff buffer now. Because essentially, with that problem, we should only ever be off by 1 or 2 ticks. It should never get to like 5 ticks off or something crazy like that, right? Okay, so we are diffing. And if we look at our buffer, you notice how all these diffs, 1, maybe 2 ticks. And that's it, right? Boop! There's our diff, right? We're only off by 1 tick. And let's move around a lot. Let's go crazy here. Actually, we could probably start getting way off because we're not resynchronizing. And this is maybe... Oh, no. Even in that case, we are still only off by 1 tick. So that's good news as well. Let's turn this back on, though. And are we going to ever get... No, we should never have more than the same ID in there. No. Run a client. And let's see if this is even something we need to correct. Because if the interpolation lurk corrects it for us and it looks fine, then we can kind of ignore it, right? And it corrects it, but it looks kind of ugly right now. You can see how it pops at the end there. It has to pop back. Boop, boop. But we do get on, we do get there. So that's just our problem. If we can keep physics in sync, right? If we can keep processing those packets, we will be okay. The other thing I want to test is a third client, which should now be a network simulation, which I have, which we're not. Sorry, so that's the other bug I want to check out right now. Because we made a change here and I haven't been able to test it yet. In our client, we are on snapshots, right? So make sure we're getting snapshots. We're readjusting the ID. We readjust the ID. Oh my God, this is not playing well with me. 1901, because we're just using real time on the client. And that's fine. We have an interpolation buffer. We haven't been able to find anything yet. I should actually check. Let me... how many... Oh, this is getting on client... Oh, both clients are getting this, of course. I just want to make sure we have data points. All right, so we do have a data point, which is the other object, right? That's the place they're at. That's its ID. Okay. Make sure we're collecting some data points in real time. Clear U. When we go and get the buffer, I want to debug through that. See what I broke. Because I want to use real time here now. Boop. And step in here. Oh my God, I need to disconnect a client in a second. Okay, I'm gonna just do that. Let's run these again. Let's cut down, which means I'm not gonna have, not gonna get an interpolation buffer now. I don't have any snapshot data. Let's see, it's update, let's find out. Oh, this is me, I messed up. I broke the interpolation buffer. I got rid of something. And just need to put it back. Started is true. We don't want to, it's just a small optimization. If we haven't added any snapshots yet, we don't want to interpolate. I think that will hopefully fix it. Let's check it out, guys. Server, start up a client. Move our clients. Let's get another client going. And there we go, right? Okay, so this client over here, here's our server space. Let's put this in the middle. As we move this around, I just want to make sure we're interpolating data correctly. Whoa. Whoa. Let it catch up. Hold on. Oh, this is fun. This is, that was our interpolation buff. That was our replay buffer catching up from the server, I guess. That was... Oh! I think I'm sending it twice right now because I have two connected clients because they're not properly separating our data right now. That's okay. But more importantly, we can see our remote entity is moving correctly. And let's see how this looks from the server view. So as we move, right, green goes first, server goes second, third client goes last, right? Because we have to send to the server, and then the server has to send over to the client. And boop, if we move, right, boom, boom. And we're simulating only about 100 milliseconds, so there should be a 200 millisecond round trip. Boom, boom, to get about 100 and so millisecond round trip to get data from me to the client. So that's pretty good, actually. And then we're also rendering 100 milliseconds in the past. So what's important to know is our interpolation buffer. We didn't break that with our tick change. We now know why client and server are out of sync from our sends. It's because sometimes we don't do a physics step when we get a network packet in and we end up losing that network packet. We need to buffer those into a queue essentially. And make sure we run all those at the right time step. So we gotta check that. Because there could be a chance where we get like two network packets and they have two different movements in them, right? We need to be able to process both of those at the same time, in the same. It's going to be a little, that's going to be odd. It's going to be a little weird. I wonder how we're going to do it. I got to think how we're going to do it. Or I should just keep buffering them up because eventually the physics should catch up and I should just keep buffering those. And every time we do a physics step, pop. Yeah, I think that's all we got to do. If you're new here, would like to support. What? Come on. You know that's not gonna work. You know that doesn't work. We do have to actually look at our interpolation buffer a little bit. It looks like we might be a little lagged. I'm gonna let this kind of catch up because I don't know why we get so far behind. It's craziness. Because we're still diffing. Oh, diffs are caught up. If you notice how here we kind of jump. So we have to look at our interpolation buffer and see, and this could be data is being sent incorrectly because I have 2 nodes and we're kind of messing some stuff up. Because we're messing some stuff up. All right, guys. Let's see if anyone is still out there. It's Thanksgiving. It's Thanksgiving. So let's fire one of these bad boys up. If you're new to the stream or you don't know what I'm about to do, it's Steam game raffle time, guys. Let's raffle off a couple of games for Thanksgiving. If you're out there, if you can hear my voice, even if you're lurking, please come back to chat for just a moment. Type anything and anything you want into chat. The bot will pick it up and will put you right into the raffle, and you'll have a chance to win some Steam games. What kind of Steam games, you ask? We have a huge list of Steam games. Well, it's dwindling until I refill it, but we have a pretty good gift list right now of some stuff to pick from. I'm going to try and pull that up if my inventory will come up, but you could also directly view my inventory by that link I just put into chat. Please go do that. I'll put it everywhere. Please click that link if you want to have a chance to win and know what's in the library. I don't know what's up with Steam right now. Looks like Steam's having some troubles. Give me a moment here, guys. Lurker represent! Yes, please, represent the lurkers out there. Let's relaunch Steam. Individually? Uh-oh. All right, let's try this again. No, I don't care about your Steam sale. Is Steam having some issues right now? Are we actually going to be able to do a raffle? Is Steam down? Is my link not working either? Let's see if Steam is down, we might have to put this on hold, guys. And I apologize if that's true. But we can't do a raffle if we got no Steam. No, it's coming up. It's coming up. Is it just super slow? We'll let it go. We'll let it see what happens. It looks like Steam is having some issues right now, though. Man, no one is out there, huh? Everyone is busy stuffing their faces with turkey. Is that what you guys are trying to tell me right now? Is it a turkey stuffing time? I mean, that's cool if it is. I'm going to be doing the same thing myself. You can't pull up my inventory? Yeah, I can't pull it up either, guys. We might have to postpone this. And, yeah, we might have to maybe do this tomorrow. All right, guys, I'm gonna go ahead and call it. It looks like Steam is down or having enough issues that we're not really gonna be able to do a raffle. And it doesn't look like there's a lot of people actually paying attention to my stream right now, which is quite all right for us to do a raffle anyway. But I will tell you this: I'm going to tonight, I'm gonna fill up some games into the bag. I'll add some games. Maybe I'll get some Humble Bumble games. We're gonna add some stuff to it, and tomorrow. And this weekend, we'll do some fun raffles. We'll make up for it. We'll make up for it, guys. But that's going to be it of the stream. It's turkey time for me. I got to go get ready. I hope you guys had fun today. I'm actually very happy. I think we finally solved our issue. We just need to go implement the solve, which we will do tomorrow. So until next time, guys. Until next time, happy Thanksgiving.